For most of human history, the night sky felt familiar. The stars returned each evening with reassuring precision. Constellations drifted across the seasons. Planets wandered among fixed patterns. Ancient civilizations built myths around them. Sailors crossed oceans beneath them. Entire calendars depended upon them, and through all of it, humanity carried a quiet assumption. We knew where we lived. Not precisely, perhaps, not in a scientific sense, but emotionally. The Earth was home. The sky was our ceiling. The stars were distant decorations scattered across a cosmic backdrop. Even after the scientific revolutions of the last few centuries shattered those beliefs, replacing Earth with a planet orbiting an ordinary star, the feeling remained. We still imagined ourselves as inhabitants of a place we understood. Then astronomy began asking a different question. Not where Earth is, not where the Sun is, but where the solar system is located inside the Milky Way itself. The answer seemed simple. For decades, textbooks confidently explained it. The Sun resides within a structure called the Orion Arm, a small spiral feature positioned between two much larger galactic arms. A minor neighborhood, an insignificant branch, a cosmic side street. Mystery solved. Or so it appeared. Yet, hidden beneath that simple explanation was a problem few people noticed. Nobody had ever actually seen the Milky Way, at least not from the outside. Every image of our galaxy hanging in museums, classrooms, documentaries, and scientific presentations shares a peculiar characteristic. None of them are photographs. They are reconstructions, interpretations, scientific artwork built from evidence. The reason is obvious once you think about it. Imagine standing deep inside a vast forest. Trees surround you in every direction. You can study nearby trunks. You can measure distances. You can map individual clearings. But drawing the entire forest becomes extraordinarily difficult because you cannot leave it. You cannot rise above it. You cannot see the whole shape. The Milky Way presents exactly the same challenge. Humanity occupies a position buried deep inside the galaxy. We are attempting to map a structure more than 100,000 light-years wide while trapped within it. And that creates uncertainty. A lot of uncertainty. Every map of the Milky Way is ultimately a detective story. Astronomers collect clues, star positions, gas clouds, radio signals, stellar motions, dust distributions. Then they attempt to reconstruct the larger picture, like archaeologists rebuilding an ancient city from scattered ruins, like detectives reconstructing a vanished crime scene from fragments of evidence. And sometimes those reconstructions change, sometimes dramatically. The Orion Arm became one of the most surprising examples. At first glance, its role seemed straightforward. The major spiral arms of the Milky Way received most of the attention. The Perseus Arm, the Sagittarius Arm, massive structures stretching across enormous portions of the galaxy. The Orion Arm appeared smaller, less important, merely a bridge connecting larger regions, a secondary feature, a cosmic afterthought. But then astronomers began collecting better data, and the picture started shifting. What if the Orion Arm wasn't merely a bridge? What if it wasn't a side street at all? What if humanity had misunderstood its galactic address? The question sounds technical, almost trivial, yet the implications reach much further than cartography, because where something exists often reveals how it formed, how it evolved, how it interacts with its environment. Consider a house. An address tells you something. A home perched beside a river experiences different forces than one located atop a mountain. A building in the center of a city lives a different existence than one isolated in the countryside. Location shapes history. Location shapes experience. Location shapes destiny. The same principle applies to stars, and perhaps even civilizations. Our solar system's location influences the radiation we encounter, the stellar neighbors surrounding us, the supernova explosions that occurred nearby in the distant past, the clouds of gas through which we travel, potentially even events that unfolded on Earth itself. But before any of those questions could be explored, astronomers needed an answer to a simpler mystery. What exactly is the Orion Arm? Surprisingly, nobody could agree. Some researchers described it as a spur, others called it a branch. Some argued it resembled a true spiral arm. Others believed it was only a temporary feature. Different models produced different conclusions. The disagreement persisted because the evidence remained incomplete. And incomplete evidence often creates confident stories that later prove wrong. History is full of such examples. Ancient maps once showed imaginary continents. Early astronomers placed Earth at the center of the cosmos. Even modern science occasionally discovers that its neatest explanations concealed deeper complexities. The Orion Arm began showing signs of becoming one of those cases. Small inconsistencies emerged. Measurements refused to align perfectly. Distances changed. Structures appeared larger than expected. Star-forming regions appeared where they shouldn't. Astronomers adjusted models, then adjusted them again. The answers improved, but so did the questions. A pattern was beginning to emerge. The more precisely scientists mapped our region of the galaxy, the less certain they became about its true nature. And that uncertainty touched something deeper, because the Orion Arm is not merely a structure among billions, it is home. Every human being who has ever lived was born within it. Every language, every empire, every war, every love story, every scientific discovery, every dream, all of it unfolded inside this mysterious galactic neighborhood. Yet we still struggle to understand its true shape. The realization feels strangely unsettling. Humanity has mapped the ocean floor, explored distant planets, detected galaxies billions of light years away. Yet our understanding of the structure surrounding us remains incomplete, as though our cosmic address were partially erased, as though the neighborhood itself were hidden beneath layers of dust, distance, and time. And perhaps that is exactly what happened, because the next stage of the investigation would reveal something unexpected. The greatest obstacle to understanding the Orion Arm was not distance, it was darkness. A darkness so vast that it concealed entire regions of our galaxy from view, and hidden behind that darkness were clues capable of changing the map itself. What astronomers discovered next would force them to reconsider everything they thought they knew about our place in the Milky Way. The mystery deepened with an uncomfortable realization. Humanity's galactic maps were being drawn through a fog. Not an ordinary fog, not clouds of water suspended in air, but immense rivers of cosmic dust stretching across thousands of light years. Silent, cold, nearly invisible, and powerful enough to hide entire sections of the Milky Way. For centuries, astronomers believed they were looking directly into the heart of our galaxy. Telescopes improved. Mirrors grew larger. Photography arrived. Observatories appeared atop mountains around the world. The stars multiplied. The sky revealed greater detail. Yet an illusion remained, because visible light, the same light our eyes evolved to see, is remarkably fragile on galactic scales. Dust absorbs it, scatters it, erases it. A distant star may shine with the brilliance of millions of suns, but enough dust between observer and source can make it vanish completely. The effect is subtle when viewed across small distances. Across tens of thousands of light years, it becomes transformative. Imagine trying to map an entire continent while dense smoke obscures most of the landscape. You might correctly identify nearby mountains. You might estimate the position of rivers, but huge regions would remain hidden. Your map would inevitably contain assumptions. The Milky Way presented exactly that problem, and nowhere was the challenge more significant than within the Orion Arm itself. At first, astronomers assumed they understood the local neighborhood reasonably well. After all, the Sun sits inside it. Surely nearby regions would be easier to study than distant galactic structures. Yet proximity created its own complications. Imagine living inside a city while attempting to determine its shape. Nearby buildings block your view. Roads twist unexpectedly. Districts overlap. The closer you examine your surroundings, the harder it can become to see the larger pattern. The Orion Arm behaved in much the same way. The closer scientists looked, the stranger it appeared. For decades, textbooks described it as the Orion Spur. Even the name carried an implication. A spur is small, secondary, temporary, a minor extension protruding from a larger structure. The terminology reflected scientific confidence. The major arms mattered. The Orion region simply connected them. Case closed. But then observations began revealing details that refused to cooperate. Star-forming regions appeared in unexpected locations. Massive molecular clouds stretched farther than anticipated. Clusters of young stars traced patterns that seemed too organized for a mere spur. The evidence did not immediately overturn existing theories. Instead, it created discomfort, the kind detectives feel when one clue refuses to fit. The kind historians experience when a newly discovered document contradicts accepted narratives. Nothing was obviously wrong, yet something felt incomplete. One of the earliest hints emerged from radio astronomy. Unlike visible light, radio waves can penetrate cosmic dust. They pass through regions that appear opaque to ordinary telescopes. Suddenly, astronomers could peer deeper into the galaxy. Structures previously hidden began emerging from darkness. Entire regions appeared where visible light observations showed almost nothing. The effect was astonishing. It was like discovering hidden rooms inside a familiar house. Rooms that had always existed. Rooms nobody realized were there. And some of those hidden structures seemed connected to the Orion Arm. The mystery intensified. If the Orion Arm were merely a small bridge, why did it contain so much activity? Why did so many young stars appear concentrated within it? Why did massive gas clouds align along its length? Questions multiplied. Answers remained elusive. Then came another clue, one that shifted the scale of the investigation. Astronomers started measuring the distances to star-forming regions with increasing precision. This sounds straightforward. It isn't. Distance is one of astronomy's oldest problems. A bright object may be nearby and faint, or distant and luminous. Without accurate distance measurements, even large structures can appear misleading. For decades, estimates contained uncertainties, reasonable uncertainties, but enough uncertainty to blur the larger picture. As new techniques improved precision, patterns emerged. Some star-forming regions, once thought unrelated, suddenly appeared connected. Others shifted position. The Orion Arm seemed to stretch farther than expected, longer, more coherent, less like a short bridge, more like something substantial. Not everyone agreed. Scientific debates intensified. One group argued that better data simply refined existing models. Another suggested the models themselves required revision. Both sides possessed evidence. Both sides possessed valid arguments. The mystery remained unresolved. Yet the tension itself was revealing. Major scientific debates rarely emerge around trivial details. Researchers were not arguing about a minor correction. They were arguing about the architecture of our galactic home. And architecture matters. Imagine discovering that your neighborhood is not a small suburb attached to a city. Imagine learning it is actually one of the city's primary districts. The roads make more sense. The population distribution changes. The history changes. Everything acquires a different context. The Orion Arm appeared to be undergoing a similar re-evaluation. But a more profound question lurked beneath the debate. How common are structures like this? The Milky Way is not unique. Across the observable universe, astronomers see countless spiral galaxies. Some possess grand, elegant arms. Others exhibit fragmented structures. Some appear orderly. Others seem chaotic. Many contain features resembling spurs, branches, feathers, and secondary arms. Yet no two galaxies are identical. The Orion Arm might represent a familiar galactic phenomenon, or it might occupy a stranger category entirely. Nobody knew. And that uncertainty opened a larger mystery. Perhaps humanity's misunderstanding was not limited to our location. Perhaps we also misunderstood the nature of spiral galaxies themselves. For generations, spiral arms were often imagined as permanent structures, cosmic equivalents of roads etched into the galaxy. But newer theories suggested something different, something far more dynamic, far more unstable. What if spiral arms are not fixed objects? What if they are temporary patterns, cosmic traffic jams through which stars drift over millions of years? If that were true, then the Orion Arm might not simply be a place. It might be an event, a transient structure frozen within a larger process, a ripple moving through a galactic ocean. The possibility changed everything. Because if our neighborhood itself is evolving, then understanding its present shape requires understanding its past. And buried within the Orion Arm were traces of ancient events, explosions, collisions, mutations, Forgotten stellar generations, remnants scattered across thousands of light years. The clues were there, but reading them would require something astronomy had never possessed before. A map detailed enough to track the positions of billions of stars. Fortunately, such a map was about to arrive. And when it did, the Orion Arm would reveal secrets nobody expected. Long before astronomers questioned the Orion Arm, they faced a more fundamental mystery. What does the Milky Way actually look like? The question sounds deceptively simple. After all, the galaxy stretches across the night sky as a luminous band visible from dark locations on Earth. Ancient civilizations noticed it thousands of years ago. They gave it names. They built stories around it. Yet for most of history, nobody understood what they were seeing. The Milky Way appeared as a pale river of light, a celestial scar crossing the heavens, a glowing wound suspended above the world. Beautiful, familiar, completely misunderstood. The first clues emerged centuries ago when telescopes revealed that the Milky Way was not a cloud at all. It was composed of countless stars, millions upon millions of distant suns packed together so densely that their light merged into a luminous haze. The discovery transformed humanity's perspective, but it created a new puzzle. If the Milky Way consisted of stars, how were those stars arranged? What shape did they form? Where was the sun located within that structure? Nobody knew. And the challenge was extraordinary. Imagine being trapped inside an immense cathedral in complete darkness. You possess only a small flashlight. You can illuminate nearby walls. You can study individual columns. You can estimate distances. But reconstructing the architecture of the entire building becomes a slow and uncertain process. The Milky Way posed exactly that problem. Astronomers occupied one tiny location within an enormous structure. Their observations resembled fragments, pieces of a puzzle whose final image remained hidden. The earliest galactic maps reflected those limitations. Researchers attempted to count stars in different directions. They measured brightness. They estimated distances. Then they assembled tentative models. Some maps portrayed the sun near the center. Others placed it elsewhere. Competing theories emerged. Confidence fluctuated. Entire generations of astronomers argued over interpretations. Yet beneath every debate lurked the same obstacle. Dust. Always dust. The invisible barrier that distorted nearly every observation. One of the most influential astronomers of the early 20th century. The Dutch scientist Jacobus Kapteyn devoted years to constructing a model of the galaxy. His work was meticulous, brilliant, and ultimately incomplete. Kapteyn concluded that the Sun occupied a position near the center of a relatively modest stellar system. The conclusion seemed reasonable. The data supported it. The scientific community largely accepted it. Then new evidence appeared. The entire model began collapsing. The reason was simple. Kapteyn had unknowingly underestimated the effects of interstellar dust. Vast regions of the galaxy were hidden. Stars vanished from surveys. Distances became distorted. The apparent center was not the true center. It was merely the furthest region observers could see through the obscuring fog. Humanity had mistaken a visibility limit for reality itself. The lesson proved profound. Sometimes what appears to be a boundary is merely the edge of observation. The universe contains many such illusions, and the Orion Arm would eventually reveal another. As the 20th century progressed, astronomers gradually realized the Milky Way was vastly larger than earlier estimates suggested. The Sun was not near the center. Instead, it occupied a position far from the galactic core, a peripheral location, not isolated, but certainly not central. The revelation carried philosophical weight. Humanity had already lost Earth's privileged status in the cosmos. Now even the Sun lost its apparent importance. We occupied neither the center of the solar system nor the center of the galaxy. We resided somewhere else, somewhere less obvious. Yet astronomers still could not determine exactly what kind of neighborhood surrounded us. The map remained blurry, the outlines uncertain, and every improvement in technology revealed additional complications. Radio astronomy opened new windows. Infrared observations penetrated dust. Space telescopes escaped Earth's atmosphere. Each breakthrough illuminated another fragment of the puzzle. Yet the puzzle itself continued expanding. This became one of astronomy's recurring paradoxes. Better data rarely eliminates mystery. It often enlarges it. Every answer exposes new questions. Every map reveals unexplored territory. Every discovery uncovers additional uncertainty. The Orion Arm benefited and suffered from this process. As observations improved, researchers gained a clearer picture of nearby stars. Young stellar nurseries emerged from darkness. Massive molecular clouds appeared. Complex structures connected regions previously thought separate. The local neighborhood grew richer, more detailed, and increasingly difficult to classify. What exactly were astronomers looking at? A spur, a branch, a spiral arm. Different observations seemed to support different conclusions. The debate intensified because classification carries implications. Names influence interpretation. If the Orion Arm is merely a spur, then it represents a minor feature, a secondary structure, a galactic side effect. If it qualifies as a genuine arm, however, its significance increases dramatically. Its formation history changes. Its dynamics change. Its relationship to the rest of the Milky Way changes. The distinction matters. And yet the evidence remained frustratingly incomplete. Astronomers found themselves trapped in an unusual situation. They possessed enough information to recognize a mystery, but not enough information to solve it. The investigation had reached an awkward middle stage. The clues existed. The pattern remained elusive, like detectives discovering fingerprints without identifying the suspect, like archaeologists uncovering foundations without finding the city. Then a technological revolution began reshaping astronomy, not through larger telescopes, not through new wavelengths, but through precision. Unprecedented precision. A new generation of instruments started measuring stellar positions with astonishing accuracy. Distances improved. Motions improved. Three-dimensional maps became possible. For the first time in history, astronomers could track stars not merely as points of light, but as moving objects occupying a dynamic galactic landscape. The effect was transformative. The forest was beginning to emerge from the trees, and hidden within that emerging picture lay one of the most important clues yet. Because as scientists mapped the positions of stars in greater detail, they noticed something peculiar. The Orion Arm was not behaving like a minor structure. Its scale appeared larger, its coherence stronger, its boundaries less obvious. The neighborhood humanity called home seemed to be growing before their eyes. But if the Orion Arm was larger than expected, another question immediately followed. How large could it really be? The answer would force astronomers to revisit assumptions that had survived for decades. And what they found next would place the solar system inside a structure far stranger than anyone anticipated. Every scientific mystery has a moment when confidence begins to fracture. Not collapse. Not disappear. Just crack. A small inconsistency appears, then another. And another. Each one seems manageable in isolation. Together, they become impossible to ignore. The Orion Arm reached that stage quietly. No dramatic announcement appeared. No single observation overturned decades of research. Instead, astronomers encountered a growing collection of clues that refused to fit comfortably inside the existing picture. At first, the discrepancies seemed technical, minor adjustments, normal scientific housekeeping. Yet buried inside those corrections was a larger story. A story about how humanity misunderstood its own galactic neighborhood. For much of the 20th century, the Orion Arm occupied a relatively modest place in Milky Way models. Researchers generally described it as a spur between the larger Sagittarius and Perseus arms. The analogy seemed reasonable. Imagine two major highways connected by a smaller road. The smaller road serves a purpose, but it is not a primary feature. That was the Orion Arm's role, or so it seemed. Then, astronomers started measuring regions of active star formation with unprecedented accuracy. Star-forming regions are useful cosmic landmarks. Unlike older stars, which may wander far from their birthplaces, young stars often remain close to the giant molecular clouds that created them. They preserve traces of galactic structure, like fresh footprints revealing the direction of a path. Researchers expected those footprints to reinforce the existing map. Instead, they complicated it. One region after another appeared farther away than anticipated. Clusters, once thought isolated, turned out to be connected. Structures extended beyond predicted boundaries. The Orion Arm began stretching, expanding. refusing to remain small. Initially, some scientists assumed measurement errors were responsible. Such caution was reasonable. Astronomy operates across immense distances. Tiny observational uncertainties can produce significant discrepancies. The scientific method demands skepticism. Extraordinary revisions require extraordinary evidence, but the evidence kept accumulating, and it came from multiple directions. Radio observations, infrared surveys, distance measurements, star-forming regions. Independent techniques started converging toward the same conclusion. The existing map might be incomplete, perhaps seriously incomplete. The situation resembled discovering that a supposedly minor river extends for thousands of additional miles beyond its documented source. At first, you question the survey, then the instruments. Eventually, you begin questioning the map itself. The Orion Arm was approaching that stage. One particularly important clue emerged from a study of masers. The term sounds unfamiliar to many people, yet these objects became critical tools in the investigation. A maser functions somewhat like a natural cosmic laser. Certain regions within giant molecular clouds amplify microwave radiation, producing bright signals detectable across enormous distances. These signals serve as exceptionally precise galactic markers. Astronomers can measure their positions with remarkable accuracy. Suddenly, distances that once contained significant uncertainty became far more reliable, and reliable distances began revealing uncomfortable truths. The Orion Arm appeared longer, much longer. Instead of resembling a short connecting bridge, it stretched across vast portions of the Milky Way. The discovery created tension, because scale changes interpretation. A village is not a city. A creek is not a river. A spur is not an arm. If the Orion structure possessed sufficient length, coherence, and star-forming activity. Perhaps astronomers had been categorizing it incorrectly all along. But classification was only the beginning. The deeper mystery involved origin. Why did the structure exist? How did it form? And what role did it play within the larger architecture of the galaxy? Those questions led scientists into one of the most fascinating debates in modern astronomy. What exactly are spiral arms? The answer may seem obvious. Look at photographs of distant spiral galaxies. Elegant luminous arms wind around bright central bulges. The structures appear permanent, stable, almost architectural, like cosmic roads carved into space. Yet appearances can be misleading. Some researchers proposed a radically different interpretation. Spiral arms may not be fixed structures at all. Instead, they could represent density waves, temporary patterns moving through vast populations of stars. A useful analogy comes from highway traffic. Imagine a traffic jam. Individual cars enter it, slow down, then eventually leave. The jam itself persists even though the vehicles continuously change. The structure exists as a pattern rather than a permanent object. Some astronomers believe spiral arms behave similarly. Stars drift into regions of higher density, remain temporarily concentrated, then move onward. The arm survives. Its individual components change. If this picture is correct, then the Orion Arm becomes far more intriguing, because it may not simply be a location. It may represent a dynamic process unfolding over millions of years. A ripple frozen within a galactic sea, a wave passing through billions of stars, and suddenly the mystery becomes larger, much larger. The question is no longer merely where the solar system resides. The question becomes what kind of environment surrounds us. Are we living inside a temporary galactic traffic pattern, a stable arm, a growing structure, a fading remnant? Nobody knew. Then came what appeared to be the first false ending, a tempting moment when the mystery seemed close to resolution. Several studies suggested that the Orion Arm possessed characteristics remarkably similar to major spiral arms. The evidence looked persuasive. The structure appeared extensive, active, well-defined. Perhaps the answer was finally emerging. Perhaps astronomers had simply underestimated its importance. For a brief period, the puzzle seemed to be converging. The neighborhood was larger than expected. Case closed. Except science rarely rewards premature certainty, because just as the picture appeared to stabilize, another complication emerged. The new observations revealed not only unexpected size, they revealed unexpected motion. Stars throughout the Orion Arm were moving in ways that hinted at a far more dynamic history. A history involving migrations, ancient disturbances, and forces that might have reshaped entire regions of the Milky Way. The map was no longer merely incomplete. It was beginning to move, and when astronomers started tracking those motions in detail, they discovered evidence pointing toward an entirely new chapter of the mystery. The investigation was about to leave geography behind and enter history. A history written not in books, but in the motions of billions of stars. Maps can tell you where something is, but movement can tell you where it came from. That realization transformed the Orion Arm investigation. For decades, astronomers had focused primarily on structure, distances, locations, shapes, boundaries. They were trying to determine what the Orion Arm looked like. Yet another question had been quietly waiting in the background. How did it get that way? The distinction matters. A photograph can show the position of a river, but it cannot explain how the river carved its path. To understand that story, you must examine motion, flow, history. The same principle applies to galaxies. The Milky Way is not a frozen object suspended in time. It is a living system. Stars orbit, gas drifts, clouds collapse, clusters disperse, entire regions evolve over millions and billions of years. Everything moves, everything changes, and hidden within those motions are traces of forgotten events. Ancient clues preserved across enormous spans of time. Astronomers began searching for those clues inside the Orion Arm. What they found complicated the mystery yet again. At first glance, the solar system appears stable. The sun rises, the planets orbit, the night sky changes slowly. Human lifetimes are too short to notice major galactic motion. This creates an illusion. The illusion of permanence. Yet beneath that calm appearance, the solar system is moving at extraordinary speed. The Sun travels around the center of the Milky Way at roughly 220 kilometers per second, every second. Our entire planetary system covers a distance greater than many nations on Earth. Every minute we move farther than the width of some continents. Every year we travel billions of kilometers through the galaxy, and still we remain trapped within the same enormous structure. The scale is difficult to grasp. Imagine boarding an aircraft capable of circling Earth dozens of times every hour. Now imagine remaining on that journey for hundreds of millions of years. That begins to approximate the Sun's galactic voyage. One complete orbit around the Milky Way requires approximately 225 to 250 million years. Astronomers sometimes call this a cosmic year, when the dinosaurs dominated Earth. The solar system occupied a different position within the galaxy. When the first mammals emerged, we were elsewhere. When Earth itself formed, the Sun resided in a completely different galactic environment. The realization raises an intriguing question. If stars are constantly moving, why does the Orion Arm still exist? Shouldn't it disperse? Shouldn't its structure dissolve over time? This became one of the central puzzles confronting researchers, and the answer, whatever it was, seemed connected to the nature of spiral arms themselves. The investigation shifted towards stellar populations. Different generations of stars leave different clues. Young stars reveal recent events. Older stars preserve deeper history. By comparing both groups, astronomers hoped to reconstruct the evolution of the Orion Arm. The process resembled archaeology. Imagine excavating an ancient city. The newest buildings occupy upper layers. Older structures lie buried beneath. Each layer preserves evidence from a different era. The Orion Arm contains similar layers, not of stone, but of stars. And those stellar layers began revealing unexpected patterns. Young stars appeared strongly concentrated along specific regions. Massive star-forming complexes traced coherent structures stretching across thousands of light years. That part made sense. Young stars tend to remain near their birthplaces. The surprise came from older populations. Many older stars displayed motions suggesting they had originated elsewhere. They appeared to be migrants, travelers. objects whose histories stretched beyond the local neighborhood. This observation hinted at something profound. The Orion Arm might not simply be a place where stars form, it might also function as a gathering point, a region where different stellar populations converge, a crossroads within the galaxy. The possibility altered the investigation. Instead of asking what the Orion Arm is, astronomers increasingly began asking what it does. The difference was subtle, but important. One question concerns structure, the other concerns function, and function often reveals deeper truths. As researchers examined stellar motions in greater detail, another anomaly emerged. The local neighborhood surrounding the Sun appeared surprisingly complex. Stars did not move as a perfectly organized population. Instead, they formed streams, groups, associations, remnants of older events. The galactic environment looked less like a neatly planned city and more like overlapping waves spreading across a vast ocean. Where did those waves originate? That question led scientists toward forgotten stellar catastrophes. Throughout galactic history, stars are born together in clusters. Thousands may emerge from a single giant molecular cloud. Initially, these stars share similar motions. Over time, gravitational interactions disperse them. The cluster dissolves. Its members spread throughout the galaxy. Yet traces of their common origin often survive. Like fragments of a shattered mirror, astronomers discovered evidence of such remnants throughout the Orion Arm. Ancient stellar siblings drifting apart. Ghostly associations whose original birthplaces had long vanished. Each remnant preserved part of a larger story. A story stretching back hundreds of millions of years. And hidden among those stories were signs of disruption, unexpected motions, disturbances, ripples propagating through stellar populations. Something had influenced this region repeatedly throughout its history. The evidence was subtle but persistent. The Orion Arm did not appear tranquil. Its present form seemed shaped by long sequences of events. Migrations, collisions, explosions, interactions unfolding across unimaginable timescales. The more researchers studied those patterns, the more they realized the local neighborhood carried scars, ancient scars. The challenge was determining their origin, and that challenge became even more urgent when scientists recognized another unsettling fact. The solar system itself may have passed through dramatically different environments during its galactic journey. Different radiation levels, different stellar densities, different nearby explosions, potentially different risks. The implications extended beyond astronomy. Could Earth's history have been influenced by our movement through the Orion Arm? Could ancient galactic events have left traces on our planet? The possibility sounded speculative, yet evidence was beginning to accumulate. The investigation was expanding. A mystery that started as galactic cartography was becoming something larger, something that connected stellar history to planetary history. But before astronomers could explore those implications, they needed a clearer picture of the structure itself. And the next clues would come not from stars, but from something even more fundamental. The vast invisible rivers of hydrogen that flow through the Milky Way, because hidden within those rivers was evidence suggesting the Orion Arm's true scale might exceed even the most ambitious estimates. And if that evidence proved correct, the mystery was far from solved. It was only entering its most revealing phase. Long before stars are born, something else exists. Something quieter. Something older. Something far easier to overlook. Hydrogen. The simplest element in the universe. One proton. One electron. Nothing more. Yet nearly every chapter of cosmic history begins with it. Stars emerge from it. Galaxies are built from it. Entire civilizations ultimately owe their existence to structures that began as drifting hydrogen clouds billions of years ago. And hidden within those clouds were clues to the Orion Arm mystery. For astronomers attempting to understand the Milky Way, hydrogen became more than a substance. It became a guide, a tracer, a way of seeing through darkness, because while stars shine brightly, they can be deceptive. Stars move, they age, they migrate. A stellar population may no longer occupy the place where it formed. Hydrogen behaves differently. Huge reservoirs of gas often preserve the larger architecture of a galaxy, like rivers tracing the contours of a landscape. Follow the rivers, and you begin understanding the terrain. The same strategy worked within the Milky Way. Researchers started tracing enormous streams of hydrogen stretching across the galaxy. The results were revealing and unsettling. To understand why, it helps to imagine the Milky Way not as a collection of stars, but as an ecosystem. An ecosystem composed of multiple layers. Stars occupy one layer, gas occupies another, dust occupies another. Invisible magnetic fields weave through them all. Together they create a dynamic environment far more complicated than simple textbook illustrations suggest. The Orion Arm existed within that environment. The question was whether the hydrogen supported the traditional picture or contradicted it. At first, the observations appeared straightforward. Hydrogen concentrations roughly aligned with known galactic structures. Spiral arms emerged as expected. The general architecture remained recognizable. Then the details arrived. And the details created trouble, because the hydrogen associated with the Orion Arm seemed unusually extensive. Large gas clouds appeared linked across enormous distances. Star-forming regions connected together. Structures, once treated as separate features, increasingly resembled parts of a continuous system. The pattern kept repeating. The Orion Arm refused to stay small. Astronomers found themselves confronting the same puzzle again and again. Every new dataset pointed in a similar direction. Every new survey hinted at greater scale. Yet scientific caution remained necessary. Galactic structures are notoriously difficult to interpret. Projection effects can create illusions. Distance uncertainties can distort patterns. Apparent connections sometimes vanish when better measurements arrive. Researchers resisted premature conclusions. They had seen false patterns before. The universe possesses a remarkable ability to fool observers. Nevertheless, the evidence continued accumulating, and with each new observation, confidence in the traditional picture weakened slightly. A useful analogy emerged. Imagine discovering a trail in a forest. At first it appears minor, a short path connecting two larger roads. Then you continue walking. The trail extends farther and farther. Soon you realize it spans much of the forest itself. The original classification no longer feels appropriate. The Orion Arm seemed to be undergoing a similar transformation. The more astronomers followed the hydrogen, the longer the structure became. The investigation gradually shifted from local mapping to galactic scale analysis. Researchers compared the Orion Arm with structures observed in external galaxies. This comparison proved important. Looking outward often helps explain what is happening nearby. After all, astronomers cannot photograph the Milky Way from outside, but they can observe thousands of other spiral galaxies. Those distant systems function like laboratories, natural experiments unfolding across the cosmos, and many of them revealed something interesting. Secondary arms were common, branches were common, complex overlapping structures were common. Galaxies rarely resembled the perfectly symmetrical spirals found in simplified illustrations. Reality was messier, more organic, more dynamic. The Milky Way appeared no exception, yet one mystery remained unresolved. Even if the Orion Arm represented a significant structure, why was it here? Why did it form in this location? What mechanism created it? The answer was not obvious. Several competing explanations emerged. One possibility involved density waves, large-scale patterns moving through the galactic disk could compress gas and trigger star formation. The Orion Arm might represent a localized manifestation of such processes. Another theory suggested interactions between larger spiral arms. Gravitational forces could generate branches and secondary structures. The Orion Arm might be a byproduct of those interactions. A third possibility proved even more intriguing. Perhaps the structure emerged through self-organization. Local gravitational effects, gas dynamics, star formation feedback, multiple processes interacting over millions of years. No single cause, no single origin. Instead, an evolving system continuously reshaping itself. The debate remains unresolved even today, and that uncertainty became part of the mystery, because the Orion Arm was beginning to resemble something difficult to categorize. Not entirely a major arm, Not entirely a minor spur, something in between, something occupying a grey zone. Science often encounters such categories: objects that resist neat labels, structures that force researchers to rethink assumptions. The Orion Arm increasingly belonged in that group. Then another clue emerged, one with implications reaching far beyond galactic geography. Hydrogen observations revealed evidence of immense cavities scattered throughout the local region. Enormous voids, gigantic bubbles, areas where gas had been swept away. The structures were astonishingly large. Some spanned hundreds of light years. Others stretched even farther. They resembled scars carved into the interstellar medium. The immediate question was obvious: what created them? Hydrogen does not simply vanish. Something had removed it. Something energetic. Something powerful. Astronomers soon identified the likely culprits. Supernovae. Many supernovae. Entire generations of exploding stars. Ancient stellar cataclysms powerful enough to reshape huge portions of the Orion Arm. Suddenly, the mystery acquired a new dimension. The local neighborhood was not merely a collection of stars and gas. It was a landscape shaped by violence. A terrain carrying the remnants of forgotten explosions. And some of those explosions may have occurred surprisingly close to the solar system. The implications were difficult to ignore, because if the Orion Arm's history included repeated waves of stellar destruction, then Earth's environment may have been influenced by those events, perhaps more than anyone realized. The investigation was no longer confined to the structure of the galaxy. It was beginning to intersect with the history of our planet. But before astronomers could connect those threads, they faced another obstacle. The greatest obstacle of all, a veil of cosmic dust so extensive that it had concealed major portions of the Orion Arm for generations. And behind that veil waited some of the most important evidence yet. Evidence that would fundamentally change the map. Every investigation encounters a suspect hiding in plain sight, not because it is especially clever, not because it actively resists discovery, but because it becomes so familiar that nobody notices its influence. For astronomers studying the Milky Way, that suspect was dust. Tiny particles, microscopic grains, fragments of carbon, silicates, ice, and heavier elements forged in ancient stars. Individually insignificant, collectively transformative. Entire regions of the galaxy disappeared behind them. Entire generations of scientists unknowingly built maps distorted by their presence. And nowhere was that distortion more consequential than within the Orion Arm. The irony was profound. Humanity had developed telescopes capable of observing galaxies billions of light years away. We could detect black holes, measure exoplanets, observe the remnants of the early universe. Yet enormous portions of our own galactic neighborhood remained hidden, not because they were distant, because they were obscured. The realization resembled discovering secret rooms inside your own house, rooms concealed not by locks, but by walls you never realized existed. The Orion Arm contained many such rooms. For decades, visible light astronomy imposed severe limitations on galactic mapping. Observers could only see so far before dust absorbed and scattered incoming light. The effect worsened with distance. Stars faded, clusters vanished. Entire structures became fragmented. Maps appeared incomplete because reality itself seemed incomplete. Yet reality was not incomplete. Observation was. This distinction would become one of the most important lessons of the investigation. Sometimes the universe does not hide answers. Sometimes our methods prevent us from seeing them. Astronomers gradually learned how to bypass the problem. Radio telescopes helped. Infrared instruments helped. Space observatories helped. Each technological advance peeled back another layer of obscuration, and each removed layer revealed a more complicated Orion Arm. At first, the discoveries appeared incremental. Additional stars, additional clouds, additional regions of star formation, useful information, nothing revolutionary. Then the accumulation reached a threshold. A pattern emerged. The hidden structures were not random. They formed coherent systems, connected systems. The missing pieces belonged together. Imagine examining a shredded map. One fragment reveals a river, another reveals mountains, a third reveals roads. Individually, the pieces seem disconnected. Then, enough fragments are recovered to reveal the larger landscape. Suddenly, everything changes. That moment was beginning to arrive for the Orion Arm. Infrared surveys proved particularly important. Unlike visible light, infrared radiation can penetrate much of the dust permeating the Milky Way. Regions that appeared dark and empty suddenly became crowded. Massive star-forming complexes emerged from obscurity. Young stellar populations appeared. Hidden structures materialized. The galaxy seemed to expand, not physically. Conceptually, the known Milky Way grew larger because more of it became visible. One discovery after another forced revisions. Distances changed, relationships changed, assumptions changed, and a curious pattern persisted throughout the process. The Orion Arm repeatedly appeared more significant than expected. Its hidden components strengthened the case that astronomers had underestimated its scale. But the investigation also revealed something else, something stranger. Dust was not merely hiding structures, it was recording history. That may sound impossible. Dust appears passive, lifeless, static. Yet interstellar dust preserves evidence of ancient events. Supernova explosions enrich it. Stellar winds reshape it. Shockwaves compress it. Radiation alters it. The distribution of dust becomes a historical archive, a cosmic crime scene preserving traces of past activity. Researchers began reading that archive. What they found hinted at a turbulent history. The local galactic environment surrounding the Sun appeared shaped by repeated cycles of creation and destruction. Stars formed. Stars died. Shockwaves spread outward. New generations emerged. The process repeated again and again. The Orion Arm looked less like a permanent structure and more like a constantly evolving ecosystem, an ecosystem carrying scars from previous eras. The analogy of a forest became increasingly useful. Walk through an ancient forest and you encounter traces of earlier events. Burn scars, fallen trunks, new growth emerging from old destruction. The present landscape contains remnants of its past. The Orion Arm exhibited similar behavior on a vastly larger scale, and those remnants suggested something important. The solar system's neighborhood had not always looked the way it does today. The environment surrounding Earth has changed repeatedly over cosmic time. Different stars, different gas densities, different radiation levels, different dangers. The implications were difficult to ignore. Because Earth does not exist separately from its galactic environment, it travels through it. The solar system orbits within it. Everything that happens here unfolds within a larger cosmic context. That context was becoming increasingly visible. Yet another mystery remained unresolved. If dust had hidden so much of the Orion Arm, how many other assumptions remained vulnerable? How many accepted conclusions depended upon incomplete visibility? The question struck at the heart of science itself. Knowledge is always limited by observation. Expand observation and knowledge changes. The Orion Arm investigation had already demonstrated this repeatedly. Every time astronomers gained a clearer view, the structure became more complex, more extensive, more difficult to categorize. It was as though the galaxy were resisting simplification. Then came another apparent breakthrough, another possible ending. By the early 21st century, improved observations had produced dramatically better maps. Researchers could identify star-forming regions with increasing confidence. Distances improved, structures aligned, patterns emerged. Perhaps the mystery was finally approaching resolution. Perhaps enough of the hidden landscape had been revealed. For a moment, it seemed plausible. The Orion Arm appeared larger than expected. The evidence supported that conclusion. The neighborhood was more significant than older models suggested. Case closed. Except a new instrument was preparing to change everything. Not by seeing deeper into the galaxy, not by penetrating more dust, but by measuring the positions of stars with a precision never before achieved in human history. Billions of stars, mapped individually, tracked in motion, placed within an evolving three-dimensional galaxy. The mission was called Gaia, and when its data began arriving, many existing assumptions would survive. Others would not, because Gaia was about to reveal that the Orion Arm was not merely larger than expected. It was part of a much more dynamic story than anyone had imagined. The map was finally becoming three-dimensional, and what emerged from that new perspective would transform the investigation completely. Every era of exploration has its defining map. The great ocean voyages of the 15th and 16th centuries produced new visions of Earth. Unknown coastlines emerged from blank parchment. Continents acquired shape. Entire civilizations discovered that their understanding of the world had been incomplete. Astronomy occasionally experiences similar revolutions, moments when new instruments do not merely improve knowledge, they reorganize it. The European Space Agency's Gaia mission became one of those moments, and for the Orion Arm, it would prove transformative. Before Gaia, astronomers possessed impressive maps of the Milky Way, but they remained limited. Distances often carried uncertainty. Stellar motions were incomplete. Three-dimensional structure could only be estimated. Researchers were assembling a galactic portrait from scattered clues. Gaia changed the scale of the investigation entirely. Its objective sounded deceptively simple: measure the positions of stars. Yet the execution bordered on extraordinary. Gaia would observe more than 1 billion stars, not once, repeatedly, tracking their locations, motions, and distances with unprecedented precision. The result would become the most detailed map of the Milky Way ever created, a map so comprehensive that entire areas of astronomy would be forced to adapt. The mission launched in 2013. Its data releases began reshaping scientific understanding almost immediately. For the first time, astronomers could examine vast portions of the galaxy as a dynamic system, not a collection of static points, a living structure in motion. The difference was profound. Imagine attempting to understand a city from a single photograph. Now imagine receiving a continuous video revealing traffic patterns, pedestrian movement, and daily activity. Suddenly, the city becomes intelligible in a new way. Gaia provided that kind of transition for the Milky Way. The galaxy began moving, and movement revealed secrets. One of the earliest surprises involved stellar streams. Researchers expected stars to exhibit organized orbital behavior. What they found was far more complicated. Throughout the galactic disk, stars formed patterns, waves, ridges, arcs, groups sharing common motions. The Milky Way looked less like a perfectly ordered machine and more like a disturbed body of water. Something had been stirring it. The question was what? Some clues pointed toward past interactions with smaller galaxies. The Milky Way has spent billions of years absorbing dwarf companions. Each encounter leaves traces, gravitational scars, ripples propagating through stellar populations. Gaia revealed evidence of those scars with startling clarity. The galaxy carried memories of ancient collisions, and those memories extended into the regions surrounding the Orion Arm. Suddenly, the local neighborhood acquired historical depth. The stars near the Sun were not merely occupying positions, they were participating in a story shaped by events unfolding across billions of years. But the most important revelations concerned structure. Gaia's distance measurements dramatically improved astronomers' ability to map the Orion Arm. Uncertainties shrank, relationships clarified, patterns emerged from confusion, and once again, the same conclusion kept appearing. The Orion Arm seemed more substantial than earlier models suggested. Not just slightly larger, significantly larger. Researchers increasingly described it as a major segment of galactic structure, a feature extending across roughly 20,000 light-years, far too extensive to dismiss as a trivial bridge. The implications were enormous. Imagine discovering that your supposedly minor neighborhood occupies a substantial fraction of an entire nation. The scale alone changes perception. The Orion Arm was undergoing a similar transformation, but size was only part of the story. Gaia also revealed coherence. Stars associated with the Orion Arm displayed patterns suggesting the structure possessed greater organizational integrity than expected. It was not simply a loose collection of unrelated regions. Connections existed, relationships existed, a larger pattern was becoming visible. The mystery appeared to be approaching resolution. The Orion Arm was larger, more organized, more important. Perhaps that was the answer. Perhaps humanity had simply underestimated its home. This became the second major false ending of the investigation. Because the data seemed convincing, the puzzle pieces appeared to align. The structure looked substantial. The case looked nearly closed. Then astronomers examined the motions more carefully, and everything became complicated again. The stars did not behave exactly as predicted. Different populations exhibited different patterns. Some moved together, others diverged. Substructures appeared, hidden layers emerged. The Orion Arm looked less like a single object and more like multiple processes overlapping in space. The analogy of a city became useful again. From above, a city may appear unified. Look closer and countless systems emerge. Transportation networks, economic districts, historical neighborhoods, population flows, overlapping structures occupying the same geographic space. The Orion Arm increasingly resembled that kind of complexity, a place where different galactic processes intersect, not merely a structure, a crossroads. The realization shifted the investigation once more. Astronomers were no longer asking whether the Orion Arm was large. The evidence strongly suggested it was. Instead, they began asking why such a structure existed at all. What mechanism maintained it? What forces shaped it? And why did the solar system occupy this particular region? The last question carried special significance, because Gaia's data also improved our understanding of the Sun's motion through the galaxy. The solar system was not passively sitting inside the Orion Arm. It was traveling through a dynamic environment, an environment shaped by stellar births, stellar deaths, gas flows, and gravitational disturbances. The neighborhood itself was evolving, and that evolution raised an unsettling possibility. Perhaps the Orion Arm is not a permanent structure. Perhaps its current appearance represents only one moment in a much longer history. A snapshot. A temporary arrangement destined to change. If so, then understanding its future requires understanding its past. And Gaia had uncovered evidence pointing toward ancient episodes of star formation, powerful enough to reshape entire regions of the galaxy. Massive stellar nurseries, gigantic associations, generations of stars born together, many of them long gone. Yet their influence remained. Ghosts lingering within the structure, traces waiting to be decoded. The investigation was no longer merely mapping the Orion Arm, it was reconstructing its biography. A biography written across millions of years, and hidden within that biography were clues suggesting our galactic neighborhood may have experienced episodes of violence far greater than previously imagined. The next chapter would follow those clues into one of the most active regions of the Milky Way. A region where stars are still being born today. A region whose existence may hold the key to understanding why the Orion Arm became the home of the solar system in the first place. There comes a point in every investigation when a suspect can no longer be dismissed. Not because the case is solved, not because every question has been answered, but because the weight of evidence becomes impossible to overlook. The Orion Arm was reaching that point. For decades, it had occupied a secondary role in descriptions of the Milky Way, a spur, a branch, a connecting feature between larger spiral arms. Useful, interesting, but ultimately minor. Now that narrative was beginning to collapse. Not dramatically, not all at once, but steadily. Like an old map slowly fading beneath the pressure of new discoveries. The challenge was no longer proving that the Orion Arm existed. That had never been in doubt. The challenge was understanding what kind of structure it truly represented, and the more astronomers investigated, the harder it became to classify. One reason involved scale. Human intuition struggles with galactic distances. 1,000 light-years sounds enormous. 10,000 light-years sounds even larger. Yet both numbers quickly lose meaning. The mind lacks a reference point to appreciate what astronomers were discovering. Another analogy becomes useful. Imagine a continent. Now imagine identifying a feature believed to be a short connecting valley between two mountain ranges. Later surveys reveal that the valley stretches across a significant fraction of the continent itself. The feature remains the same, yet your interpretation changes completely. The Orion Arm underwent a similar transformation. As measurements improved, its apparent length expanded. Star-forming regions aligned across astonishing distances. Massive molecular clouds traced coherent patterns. Clusters of young stars marked pathways extending thousands upon thousands of light-years. The structure appeared less fragmented, more organized, more substantial. Eventually, many researchers began referring to it as the Orion Cygnus Arm. The name itself reflected changing perceptions. A larger structure demanded a larger identity. Yet size alone could not settle the debate. A long structure is not necessarily a major spiral arm. The universe frequently produces elongated features, filaments, streams, bridges, Classification required deeper analysis. Astronomers therefore turned their attention toward activity. What was happening inside the Orion Arm? The answer proved remarkable. This region contained numerous stellar nurseries, enormous clouds of gas and dust where new stars continued forming. Some of the most famous star-forming regions visible from Earth belonged to this neighborhood. The Orion Nebula, the Cygnus X Complex, the Eagle Nebula, the Lagoon Nebula, the Trifid Nebula. These names often appear separately in astronomy books. Yet, viewed from a galactic perspective, many represent chapters within the same larger story. The Orion Arm was not dormant. It was productive, actively generating stars, actively reshaping itself, actively participating in the evolution of the Milky Way. That realization created another mystery. Why here? Why does this region contain so much activity? Why does the solar system occupy a neighborhood filled with stellar nurseries? The answer was not obvious, and it forced astronomers to examine the Orion Arm not merely as a structure, but as an environment. The distinction mattered. Structures can be mapped. Environments must be understood. An environment influences everything inside it. Weather shapes ecosystems. Oceans shape coastlines. Galactic environments shape stars and planetary systems, including our own. Researchers began studying the broader context surrounding the solar system. The results were intriguing. The Sun resides in a relatively low-density region known as the local bubble. This enormous cavity extends for hundreds of light years. Compared with neighboring areas, it contains unusually little gas, unusually little dust. The solar system occupies a surprisingly open space. At first glance, this seems fortunate. Dense interstellar clouds can produce complicated effects. Radiation environments change. Gravitational influences increase. Star formation becomes more intense. The local bubble appears comparatively calm, but calm environments often possess violent origins, and the local bubble proved no exception. Evidence suggested that multiple supernova explosions created it. Ancient stars lived, died, exploded. Their shockwaves swept gas outward, carving a vast cavity through the interstellar medium. The solar system now drifts inside the remnant, a ghostly chamber formed by stellar destruction. The implication was unsettling. Our neighborhood's apparent tranquility resulted from ancient violence, and that violence connected directly to the larger history of the Orion Arm. The region surrounding the Sun was not random. It was shaped, sculpted, modified by events unfolding over millions of years. The realization introduced another layer of mystery, because those explosions belonged to previous generations of stars that no longer exist. Yet their influence remains. In a sense, the solar system inhabits a landscape created by ghosts. The concept feels poetic, but it is also scientifically accurate. Many of the structures astronomers observe today originated from stars that vanished long ago. The present contains remnants of the past, echoes hidden within gas clouds, echoes hidden within stellar motions, echoes hidden within the architecture of the Orion Arm itself. The more researchers studied those echoes, the more dynamic the region appeared. This was not a static neighborhood. It was a place of ongoing transformation. Stars forming, stars dying, shock waves spreading, clouds collapsing, everything changing. The Milky Way began looking less like a machine and more like a living ecosystem. An ecosystem operating on timescales so immense that human history becomes nearly invisible. Yet another question emerged. Perhaps the most intriguing one yet. If the Orion Arm is this active today, what did it look like in the distant past? And what will it become in the distant future? The answer mattered because spiral structures are not permanent. Galactic environments evolve, patterns shift, regions migrate. The neighborhood surrounding the solar system may have looked dramatically different hundreds of millions of years ago, and it may look dramatically different hundreds of millions of years from now. The realization transformed the mystery once again. The Orion Arm was no longer merely a location. It was a chapter within an ongoing process, a temporary arrangement inside a larger galactic story, a story whose beginning remained uncertain, a story whose ending had not yet arrived. And just as astronomers began appreciating the scale of that story, a deeper problem emerged. A problem reaching beyond the Orion Arm itself, because understanding our neighborhood ultimately required understanding something even more mysterious: the very nature of spiral arms. And the closer scientists examined that question, the more they realized that the Milky Way might not work the way anyone once imagined. At first glance, spiral galaxies seem straightforward. They are among the most recognizable objects in the universe. A bright, central bulge, graceful spiral arms winding outward, elegant symmetry suspended in darkness. The design appears almost intentional, almost architectural, as though some cosmic engineer carefully arranged billions of stars into a giant rotating pattern. For generations, astronomers viewed spiral galaxies in much the same way. The arms looked permanent, stable, long-lived. Natural equivalents of roads carved into the galactic landscape. The Orion Arm inherited that assumption. If spiral arms were fixed structures, then understanding our location inside one became relatively simple. Find the arm, map its shape, determine its position, mystery solved. But nature rarely rewards simple assumptions, and the deeper astronomers investigated spiral galaxies, the stranger those structures became. The first clue emerged from an apparent contradiction. Stars orbit the galactic center at different speeds. Inner regions move faster. Outer regions move more slowly. This phenomenon is known as differential rotation. It creates a problem, a serious one. Imagine drawing a spiral pattern on a rotating disk. If the inner portion rotates faster than the outer portion, the spiral begins winding tighter and tighter over time. Eventually it becomes distorted beyond recognition. The process is unavoidable. Yet spiral galaxies clearly maintain their arms. Some have existed for billions of years. Why haven't those structures wound themselves into impossibly tight coils? The contradiction became known as the winding problem, and it haunted astronomy for decades. The universe appeared to be violating expectations. Something was missing. Something fundamental. Researchers proposed numerous solutions. Many failed. Some survived. Eventually, a powerful idea emerged. Perhaps spiral arms are not collections of fixed stars. Perhaps they are patterns. This concept initially feels counterintuitive, yet familiar examples exist all around us. Consider a stadium wave. Thousands of spectators rise and sit. The wave moves around the arena, yet the people themselves remain largely in place. The pattern travels. The participants change. The structure exists independently of any individual component. Density wave theory suggested that spiral arms behave similarly. Stars drift through them. Gas drifts through them. The arm persists. Its contents continuously change. The analogy transformed astronomy. Suddenly, spiral arms became dynamic phenomena rather than permanent objects. Not roads, traffic patterns, not structures carved into the galaxy, waves propagating through it. The theory explained many observations. Gas entering a spiral arm becomes compressed. Compression triggers star formation. New stars emerge. Massive blue stars illuminate the region. The arm appears bright, active, distinct. Over time, those stars continue moving. New stars replace them. The pattern survives. For a while, the mystery seemed solved. The winding problem had an elegant explanation. Spiral arms were density waves. Case closed. This became the third major false ending of the Orion Arm investigation, because, as observations improved, astronomers discovered complications. Again, always complications. Some galaxies fit density wave predictions remarkably well, others did not. Certain spiral arms appeared transient, short-lived, fragmented. Computer simulations generated structures that formed, dissolved, and reformed repeatedly. The universe refused to conform to a single model. Reality was messier, more dynamic, more unpredictable. The Orion Arm occupied the center of this uncertainty because its characteristics seemed inconsistent. Some properties resembled classical spiral arms, others resembled temporary structures. Still others suggested entirely different processes. Researchers found themselves confronting an uncomfortable possibility. The Orion Arm might not belong neatly within any category, and if that were true, understanding it would require a broader view of galactic architecture. The investigation expanded outward. Astronomers began comparing the Milky Way with distant galaxies observed across the cosmos. The results were illuminating. Many spiral galaxies displayed features resembling the Orion Arm: secondary arms, feathers, branches, spurs, substructures extending away from larger patterns. These features appeared common, yet their origins remained debated. Some emerged through gravitational interactions, others developed through instabilities within the galactic disk. Still others formed through processes not yet fully understood. No universal explanation existed. The diversity suggested an important lesson. Galaxies are not machines following identical blueprints. They are ecosystems, complex systems shaped by countless interacting influences. Gas dynamics, gravity, star formation, magnetic fields, dark matter, feedback from supernova explosions, all operating simultaneously. The Orion Arm likely emerged from that complexity, not from a single cause, but from multiple causes interacting across immense timescales. This interpretation carried significant implications. If galactic structure arises from evolving processes rather than fixed designs, then the Milky Way is constantly changing. Spiral arms appear, shift, fade, reorganize. The galaxy we inhabit today differs from the galaxy that existed hundreds of millions of years ago, and it will differ from the galaxy that exists hundreds of millions of years from now. The realization feels almost unsettling. Human beings often imagine galaxies as eternal, timeless, unchanging. In reality, they are histories unfolding across cosmic time. The Orion Arm represents one chapter, not the entire story. Yet another mystery emerged from this perspective. If the Orion Arm is evolving, then where was the solar system when earlier versions existed? The Sun has completed roughly 20 galactic orbits since its formation, 20 journeys around the Milky Way, 20 opportunities to encounter different environments, different neighbors, different risks, different opportunities. The implication was profound. Earth's history may not merely be the history of a planet. It may also be the history of a galactic voyage. A voyage through changing regions of the Orion Arm, or perhaps through structures that no longer exist at all. The thought transformed scale once again. The investigation had begun with a simple question about location. Now it was becoming a question about time, about movement, about history. The solar system was not simply living inside the Orion Arm. It was traveling through an evolving galactic landscape, and hidden within that journey were clues to some of the most remarkable events in Earth's past. Events that may connect planetary history to galactic history. Events whose traces remain buried beneath millions of years. The next stage of the investigation would follow the Sun itself, because understanding the Orion Arm ultimately required understanding the traveller moving through it, and the solar system's journey would reveal just how lost and how fortunate we may actually be. Every year, Earth completes another orbit around the Sun. The journey feels significant. 940 million kilometers, a complete circuit through space. The passage of seasons, the rhythm of life itself, for most people. That orbit defines motion on the grandest imaginable scale. Yet from the perspective of the Milky Way, it is almost invisible. A tiny circle carried along by a much larger voyage. A voyage so vast that human civilization has experienced only a fraction of a single step. The true journey belongs to the Sun, and through it, to all of us. At this very moment, the solar system is moving through the Orion Arm, not drifting, not slowly wandering, traveling at extraordinary speed. The Sun races around the center of the Milky Way at roughly 220 kilometers every second. Every planet, every moon, every asteroid, every living organism on Earth accompanies it. We are passengers aboard a vessel we rarely notice moving. The sensation is absent because everything around us shares the journey. The illusion resembles sitting inside a smooth aircraft at cruising altitude without looking through the window. Motion disappears. Only perspective reveals the truth. And perspective is exactly what astronomy provides. When scientists reconstructed the Sun's galactic orbit, they uncovered something fascinating. The solar system is not merely circling the galaxy. Its path oscillates. It rises and falls relative to the galactic plane. It drifts through regions of differing density. It encounters changing stellar neighborhoods. The journey resembles the motion of a horse on a carousel. The horse travels around the center, but it also moves up and down. The combined motion creates a more complicated trajectory than simple rotation. The Sun behaves similarly. This realization transformed the Orion Arm mystery because it suggested that our galactic environment has never been constant. The region surrounding Earth today differs from the region that surrounded Earth millions of years ago, and that difference may matter a great deal. To understand why, imagine driving across a continent. You pass through deserts, forests, mountains, cities, coastlines. The landscape changes, the weather changes, the risks change, the resources change. Even if your vehicle remains the same, the environment influences the journey. The solar system experiences a cosmic equivalent. Different regions of the galaxy contain different conditions, different concentrations of stars, different amounts of gas and dust, different frequencies of supernova explosions, different radiation environments. The Sun's orbit carries us through them all. The implications become particularly intriguing when researchers examine Earth's geological history. For decades, scientists notice patterns that seemed difficult to explain: mass extinctions, climate shifts, periods of elevated cosmic radiation. Most possess plausible terrestrial explanations: volcanism, impacts, atmospheric changes. Yet some researchers wondered whether galactic influences might occasionally contribute. Could the solar system's journey through the Milky Way affect conditions on Earth? The idea remains controversial. Evidence is mixed. Many proposed correlations have weakened under scrutiny. Others remain open questions. What matters for our investigation is not whether every claim proves correct. What matters is the underlying principle. Earth does not exist in isolation. It occupies a galactic environment, and environments matter. The Orion Arm forms part of that environment. The realization deepens the significance of our location. The Orion Arm is no longer merely an address. It becomes a context, a setting within which Earth's history unfolds. And understanding that setting requires reconstructing the Sun's past. Astronomers therefore began tracing the solar system backward through time. Where was the Sun when dinosaurs dominated Earth? Where was it when multicellular life emerged? Where was it when the planet itself formed? The answers carried uncertainty. Galactic dynamics are complex. Tiny errors accumulate over immense timescales, yet broad patterns emerged. The Sun appears to have remained within the general vicinity of the Orion Arm for a substantial portion of its history, not necessarily in exactly the same position, not surrounded by the same stars, but occupying a related galactic neighborhood. That continuity may not be accidental. Some researchers suggest that regions like the Orion Arm offer favorable conditions for long-term planetary stability. Not too crowded, not too sparse, not too close to the energetic chaos near the galactic center, not too isolated from the materials necessary for star and planet formation. The analogy often used is urban planning. Imagine searching for an ideal place to build a city, a location near resources but away from major hazards, accessible but not overcrowded, active but not chaotic. The Orion Arm may occupy a comparable position within the Milky Way. If true, that possibility raises a profound question. Did our location help make complex life possible? The idea remains speculative, yet it is difficult to ignore. The solar system appears to reside in a surprisingly moderate environment, close enough to stellar activity to inherit heavy elements forged in earlier generations of stars, far enough from extreme galactic hazards to enjoy long periods of relative stability. A balance, a compromise. A cosmic middle ground. For a moment, the mystery seems almost comforting. Perhaps we have finally found the explanation. Perhaps the Orion Arm is simply a favorable neighborhood, a fortunate location within a vast galaxy. Another answer, another ending. Yet once again, the evidence refuses to cooperate, because the Orion Arm carries scars. Ancient scars. Evidence of violent events capable of reshaping enormous regions of space. The local environment may be relatively calm today. That does not mean it was always calm. In fact, evidence increasingly suggests the opposite. The solar system appears to inhabit the aftermath of multiple stellar catastrophes, explosions powerful enough to carve cavities hundreds of light-years wide, events capable of altering the structure of entire sections of the Orion Arm. The tranquility surrounding us may be temporary, a pause following ancient turbulence, and hidden within those ancient catastrophes are clues to another mystery. A mystery involving vanished stars, forgotten stellar generations, and explosions whose echoes may still linger around us today. To understand the true history of the Orion Arm, astronomers would need to investigate those echoes, because the next discovery would reveal that our galactic neighborhood is built upon the remnants of stars that died long before humanity ever appeared. The night sky feels peaceful. That impression is understandable. Stars shine steadily. Constellations change slowly. The heavens appear calm, orderly, almost eternal. Yet, appearances can be deceptive. Beneath the quiet surface of the Orion Arm lies a history written in violence. A history hidden not in ancient ruins or fossil records, but in expanding shockwaves, drifting atoms, and ghostly cavities carved into interstellar space. The deeper astronomers investigated our galactic neighborhood, the clearer one fact became. The region surrounding the solar system is not pristine. It is a remnant, a landscape shaped by catastrophes that unfolded long before humanity existed. And those catastrophes may hold the key to understanding why the Orion Arm looks the way it does today. The story begins with stars. Not ordinary stars like the sun, massive stars, giants, dozens of times heavier than our own star. These objects live fast and die young. They burn through their nuclear fuel with astonishing intensity. For millions of years, they flood surrounding space with radiation and powerful stellar winds. Then, when their fuel is exhausted, they die. Not quietly, but catastrophically. A supernova releases more energy in moments than the sun will produce across its entire lifetime. The explosion launches shockwaves through surrounding space. Gas is compressed. Dust is displaced. New star formation may be triggered. Entire regions of a galaxy can be transformed. One supernova is significant. Many supernovae become something else entirely. They become architects. Throughout the Orion Arm, astronomers discovered evidence of exactly such architects. Huge cavities scattered through the local interstellar medium, regions where gas had been swept aside, regions too large to explain through ordinary processes. The structures looked like wounds, ancient wounds, and like wounds, they preserved traces of the events that created them. Among the most intriguing of these structures is the local bubble. The solar system currently resides inside it. The name sounds modest. The reality is anything but. The local bubble spans roughly 1,000 light-years across, a vast chamber of low-density gas surrounding our cosmic neighborhood. Compared to nearby regions, it contains remarkably little material. It is, in effect, an enormous cavity in the Orion Arm. The obvious question follows immediately. How do you create a cavity that large? Astronomers spent years investigating. Gradually, a consensus emerged. The most likely explanation involved a chain of supernova explosions. Not one, not two, possibly dozens. Over millions of years, generations of massive stars lived and died. Their combined shockwaves swept surrounding gas outward. The local bubble emerged from the aftermath. The implication is extraordinary. The solar system drifts through the interior of a structure created by vanished stars. Stars that no longer exist. Stars whose deaths occurred before humans evolved. Yet whose influence still shapes our environment today. The realization feels almost haunting. Our galactic neighborhood is partly constructed from ghosts. But the mystery deepened because astronomers began tracing the origins of those explosions. The evidence pointed toward ancient stellar associations, groups of massive stars born together, clusters that have long since dispersed. Their members drifted apart across the galaxy. Their original homes disappeared, yet their fingerprints remained. The process resembles investigating an ancient civilization. The city is gone. The inhabitants are gone. The buildings have vanished. Yet scattered artifacts allow historians to reconstruct the story. Astronomers were performing a similar reconstruction, except the artifacts were stars, gas clouds, shock waves, and motion. Especially motion. Gaia's precise measurements proved invaluable. By tracing stellar trajectories backward through time, researchers identified populations likely connected to the events that created the local bubble. The evidence suggested a sequence of stellar generations: birth, evolution, explosion, renewed star formation, then repetition, again and again. The Orion Arm revealed itself as a place of continual renewal, destruction creating opportunity, death enabling creation. The cycle repeated across millions of years. This realization provided a new perspective on galactic structure. Perhaps spiral arms are not merely concentrations of stars. Perhaps they are engines of transformation, regions where gas gathers, stars form, stars die. The process sustains itself. The Orion Arm increasingly resembled such an engine, a dynamic ecosystem rather than a static object. Yet another question emerged, one with unsettling implications. How close were these ancient explosions to Earth? The answer matters because supernovae influence more than galactic architecture. Nearby explosions can affect planetary environments. Radiation levels increase. Cosmic rays intensify. Atmospheric chemistry may change. Most supernovae occur far enough away to pose little danger, but geological evidence suggests that relatively nearby events have occurred during Earth's history. One clue comes from an unusual isotope, Iron 60. This radioactive form of iron is produced in supernova explosions. It does not naturally persist for billions of years. If it is found on Earth, something must have delivered it more recently. Researchers discovered traces of Iron 60 in deep ocean sediments. The isotope appears to have arrived millions of years ago. The most likely source, a nearby supernova. The evidence does not indicate a catastrophe for life. Earth survived, clearly. But it demonstrates something remarkable. Events within the Orion Arm can leave measurable traces on our planet. The boundary between galactic history and terrestrial history is not absolute. The two stories intersect. That realization dramatically raises the stakes. The Orion Arm is no longer simply our location. It is part of the environmental history of Earth itself. And that history may be more dynamic than anyone once imagined. For a moment, another interpretation seemed possible. Perhaps the mystery was finally yielding answers. The local bubble explained. Ancient supernovae identified. The neighborhood's scars accounted for. Case closed. Except new observations complicated matters again, because the local bubble was not isolated. Researchers discovered connections to larger networks of cavities and structures extending across the Orion Arm. The region appeared interconnected, part of a broader pattern, a much larger pattern. The local scars belonged to something bigger, something stretching far beyond the solar system. And as astronomers followed those connections outward, the scale of the mystery expanded once more. The Orion Arm was no longer just a neighborhood. It was beginning to look like a vast evolving tapestry, woven from generations of stars, a tapestry whose true shape was only now becoming visible, and the revelations waiting beyond it would challenge humanity's understanding of its place inside the Milky Way itself. For centuries, humanity's understanding of the Milky Way suffered from a simple limitation. We were trapped inside it. Every map, every theory, every reconstruction began from that unavoidable constraint. Imagine attempting to understand the shape of a vast labyrinth while standing somewhere deep inside its corridors. You can explore nearby passages. You can sketch local features, but the overall design remains elusive. The Orion Arm mystery emerged from precisely that problem. Yet by the early 21st century, something extraordinary had happened. Enough clues had accumulated. Enough observations had converged. Enough hidden regions had been revealed. For the first time, astronomers could begin seeing the larger pattern. And what emerged from the darkness was not what earlier generations expected. The revelation did not arrive as a single discovery. It emerged gradually, like an image developing inside an old photographic plate. Each new observation sharpened the picture. Each new dataset reduced uncertainty. Slowly, the Orion Arm transformed from a vague feature into something more substantial, more coherent, more significant. The evidence no longer supported the old description comfortably. Calling the Orion Arm a minor spur increasingly felt inadequate. Not necessarily wrong, but incomplete. The distinction mattered because science often advances through improved descriptions rather than absolute reversals. The Earth is not flat, but it is also not perfectly spherical. Reality tends to occupy more nuanced territory. The Orion Arm appeared to belong in that category. Researchers now recognized it as a major star-forming segment extending across tens of thousands of light years. It connected important regions of galactic activity. It contained enormous molecular clouds. It hosted vast populations of young stars. It possessed organizational coherence, difficult to dismiss. The neighborhood surrounding the solar system was not a tiny appendage hanging off larger structures. It was part of a substantial galactic feature. Humanity's address had become larger, and with that realization came a shift in perspective. For decades, the solar system seemed tucked away inside a relatively insignificant corner of the Milky Way. Now the evidence suggested something different. Not centrality, not special privilege, but meaningful context. The Orion Arm was not the galaxy's center. It was not the largest spiral structure, yet it was far from insignificant. It represented a major component of the Milky Way's ongoing evolution, and that meant humanity occupied a more active galactic neighborhood than previously imagined. The revelation created an interesting psychological effect. Scale changed, yet importance changed as well. Consider a city. A person living in a small alley may feel peripheral to the larger urban story. Discover that the alley is actually part of a major district, and the context shifts. The individual remains small. The environment becomes more meaningful. Something similar happened with the Orion Arm. Humanity remained cosmically tiny, yet our neighborhood acquired new significance. The discovery also resolved certain long-standing puzzles. The abundance of nearby star-forming regions made more sense. The distribution of molecular clouds made more sense. The alignment of stellar populations made more sense. Many previously disconnected observations began fitting together. The investigation appeared to be converging. A coherent picture emerged. The Orion Arm was larger than expected, more organized than expected, more important than expected. For a moment, the mystery seemed close to completion, but every major scientific revelation contains a hidden danger. The temptation to stop asking questions, the temptation to declare victory, the temptation to mistake clarity for finality. Astronomers avoided that trap, because even as the larger picture became clearer, new complications emerged, and those complications pointed toward deeper mysteries. One involved origin. Understanding what the Orion Arm is does not necessarily explain how it formed. The distinction is crucial. An archaeologist may identify an ancient city. That does not automatically reveal who built it. The Orion Arm presented a similar challenge. Researchers still disagreed about the mechanisms responsible for its existence. Density waves, local instabilities, interactions between larger spiral arms, feedback from star formation. Different models emphasized different processes. No single explanation achieved universal acceptance. The structure's identity became clearer. Its birth remained uncertain. Another complication involved time. The Orion Arm observed today represents only a snapshot, a temporary state within a continuously evolving galaxy. Future observations may reveal changes. Future simulations may revise interpretations. The story remains unfinished. And then there was the most profound mystery of all. Why does the solar system occupy this particular location? Not merely geographically, historically. The Sun formed approximately 4.6 billion years ago. During that immense span of time, countless possible environments existed within the Milky Way. Yet our planetary system emerged here, within this region, inside this arm. Was that coincidence? Necessity? Chance? The question touches deeper themes than astronomy alone, because location influences possibility. Different environments produce different outcomes. A star forming near the galactic center faces different conditions than one forming in the outer disk. Different radiation levels, different stellar densities, different histories. The Orion Arm may have provided conditions favorable to long-term planetary stability, perhaps even favourable to complex life. The idea remains speculative, but it remains difficult to ignore. And as researchers explored those possibilities, another perspective emerged, a perspective that transformed the entire investigation. The Orion Arm was not merely a structure surrounding humanity. It was a structure that humanity could only understand because it existed within it. We are participants in the story we are attempting to reconstruct, observers embedded inside the phenomenon itself. The situation resembles trying to write the history of a city while living inside its streets. The challenge is immense. Perspective becomes difficult. Bias becomes unavoidable. Yet the effort continues. That effort itself reveals something remarkable about science. Knowledge advances not through certainty, but through refinement. Maps improve. Questions evolve. Mysteries deepen. The Orion Arm investigation embodies that process perfectly. What began as a simple classification problem evolved into a broader exploration of galactic structure, stellar history, and humanity's place within the Milky Way. And despite all the progress, the largest implications are only beginning to emerge. Because the next discovery would challenge not merely our understanding of the Orion Arm, it would challenge our understanding of the galaxy itself. The revelation beneath the dust was significant. What came next would be even larger. The history of science contains a recurring pattern. A mystery grows, evidence accumulates, a solution appears. The pieces seem to fit. Researchers relax. Then new observations arrive, and the mystery becomes larger than before. The Orion Arm was about to experience exactly that cycle. By this stage of the investigation, the broad outline appeared reassuringly clear. The old image of a tiny, insignificant spur had largely faded. The Orion Arm had emerged as a major galactic structure. Large, active, coherent. An important component of the Milky Way's architecture. Many questions remained, but the central mystery seemed close to resolution. Humanity's cosmic neighborhood had finally been identified, or so it appeared. Yet beneath the apparent clarity, unresolved tensions persisted. Small inconsistencies, subtle anomalies, details that refused to settle comfortably into the new picture. And history repeatedly demonstrates that scientific revolutions often begin with details, not grand contradictions, tiny ones. The first warning signs emerged from simulations. As computer models of galactic evolution became increasingly sophisticated, astronomers attempted to recreate structures resembling the Orion Arm. Sometimes they succeeded, sometimes they failed. Different assumptions produced different outcomes. A density wave could generate something similar. So could local gravitational instabilities. So could interactions between larger spiral arms. The problem was not a lack of explanations. The problem was an abundance of them. Several models worked. None worked perfectly. The Orion Arm seemed to occupy an uncomfortable middle ground where multiple theories overlapped. This ambiguity became increasingly difficult to ignore. If a structure can be explained by several mechanisms, which explanation is correct? Perhaps all of them, perhaps none. Perhaps reality is more complicated than the available categories. Astronomers found themselves confronting an old scientific lesson. Nature rarely organizes itself according to human labels. The universe is under no obligation to fit our classifications. The Orion Arm appeared determined to remind researchers of that fact. Another complication emerged from observations of external galaxies. The Milky Way often serves as a template because it is our home. Yet studying other galaxies provides valuable perspective. Astronomers examined thousands of spiral systems across the cosmos. Many displayed structures resembling the Orion Arm. Branches, feathers, secondary arms, complex overlapping patterns. At first this seemed reassuring. The Orion Arm was not unusual. It belonged to a common galactic family. Case strengthened, mystery reduced. Then the details appeared. Those similar-looking structures formed through different processes. Some resulted from gravitational encounters. Others emerged through internal instabilities. Still others evolved through mechanisms not yet fully understood. Superficial similarity concealed deeper diversity. The implication was unsettling. The Orion Arm's appearance might not reveal its origin. Two structures can look alike while possessing completely different histories. The analogy is simple. Two cities may share similar skylines, yet one grew around a river, the other around a harbour. Appearance alone does not explain development. The same principle applies to galaxies. The Orion Arm's form may not reveal its true story, and that realization reopened the investigation. Then came another surprise. Researchers began examining stellar ages across different regions of the Orion Arm. If the structure originated through a single coherent process, certain age patterns might be expected. Instead, the data suggested complexity. Different regions carried different histories, different populations, different timelines. The structure appeared layered, composite, built from multiple chapters rather than one. Imagine reading a manuscript assembled from several books. The pages connect, the narrative flows, yet traces of separate origins remain visible. The Orion Arm increasingly resembled such a manuscript, a galactic story composed of overlapping episodes. This interpretation carried profound implications, because it suggested the structure may not possess a single origin at all. Perhaps astronomers had been asking the wrong question. Instead of asking how the Orion Arm formed, perhaps they should ask how it continues evolving. The distinction matters. One question seeks a beginning, the other seeks a process, and processes often reveal deeper truths than origins. The mystery shifted once again. The Orion Arm stopped looking like an object. It started looking like an event, an ongoing event, a region where multiple galactic influences converge and interact, a dynamic zone continuously reshaped by star formation, gravity, gas flows, and stellar death. The realization was powerful, yet it created another problem. If the Orion Arm is an evolving process, where are its boundaries? The question sounds technical. It isn't. Boundaries define identity. A nation without borders becomes difficult to map. A river without banks becomes difficult to trace. A structure without clear limits becomes difficult to classify. The Orion Arm's boundaries appeared surprisingly fuzzy. Some regions blended gradually into neighboring structures. Others contained transitional zones. The neat divisions found in simplified diagrams began dissolving. Reality looked less orderly, more organic, more fluid. This was the false solution revealing itself. Astronomers had believed the mystery was becoming simpler. Instead, greater understanding exposed deeper complexity. The Orion Arm was larger than expected, yes, but it was also less easily defined, less easily categorized, less easily explained. The solution had become another mystery, and perhaps that was inevitable, because every increase in resolution reveals additional detail. Every better map uncovers smaller features. The closer humanity looked, the richer the Orion Arm became. Then a final complication emerged, one with implications extending far beyond galactic structure. The Milky Way itself may not be entirely stable. Recent observations suggest that our galaxy is still responding to ancient interactions with smaller companions. Ripples propagate through the disk. Stars move in unexpected ways. Large-scale oscillations appear. The entire galaxy may be subtly vibrating from encounters that occurred hundreds of millions of years ago. If true, then the Orion Arm exists within a moving framework, a changing environment, a galaxy still carrying echoes of past collisions. The realization expanded the scale of the investigation yet again. The mystery was no longer confined to one arm, or even one galaxy. It became a question about how large cosmic systems evolve over time, how order emerges from complexity, how structure survives within change, and most importantly, how humanity attempts to understand phenomena from the inside. The apparent solution had dissolved. The mystery had returned, bigger than before. And the next stage of the journey would reveal a galaxy far more alive than anyone once imagined. For most of human history, the heavens appeared eternal. The stars returned each night. Constellations held their shapes. The Milky Way stretched across the darkness, unchanged. Generation after generation inherited the same sky. The impression was powerful and profoundly misleading. The universe is not static. It never was. Everything moves. Everything evolves. Everything changes. The Orion Arm investigation had already hinted at this reality. But now the evidence pointed towards something larger. Something that transformed not only our understanding of the Orion Arm, but our understanding of the Milky Way itself. The galaxy was alive. Not alive in a biological sense, alive in the sense that oceans are alive, weather systems are alive, forests are alive, complex, dynamic, continuously changing. The realization emerged from decades of increasingly precise observations. Astronomers began detecting motions that should not have existed if the Milky Way were a simple, stable system. Stars moved in coordinated patterns. Galactic regions oscillated. Structures rippled. The disk itself appeared disturbed. Something had happened, and the consequences were still unfolding. The first clues came from stellar motions revealed by Gaia. Researchers expected stars to follow relatively smooth orbits around the galactic center. Instead, they discovered enormous waves propagating through stellar populations, like ripples spreading across a pond after a stone is thrown. The analogy was more than poetic. It was surprisingly accurate. The Milky Way appeared to have been struck. Not recently, but recently enough that traces remained visible. The suspected culprit was a smaller galaxy, a dwarf companion that ventured too close to the Milky Way in the distant past. One leading candidate is the dwarf galaxy known as Sagittarius, not the Sagittarius Arm, a completely separate object, a small galaxy slowly being torn apart by the Milky Way's gravity for hundreds of millions of years. Sagittarius has plunged through our galactic disk repeatedly. Each passage disturbed the larger system. Each encounter injected energy. Each interaction left scars. Those scars are still visible today. The realization carried an extraordinary implication. The Milky Way is not an isolated structure evolving peacefully in darkness. It is participating in a long history of encounters, a history of mergers, collisions, assimilations. Galactic archaeology revealed that our home galaxy grew by consuming others. The process continues even now. The Orion Arm exists within that larger story, and suddenly many mysteries began appearing in a new light. Perhaps the unusual motions observed near the Orion Arm were not purely local phenomena. Perhaps they reflected disturbances propagating across the entire galaxy. Perhaps our neighborhood's history could not be understood independently. It might be connected to events unfolding on much larger scales. The investigation widened once again. A recurring theme had emerged throughout this documentary. Every apparent answer led to a larger question. Every solved mystery revealed a bigger one behind it. The Orion Arm was following the same pattern. At first, the mystery concerned location, then structure, then origin. Now it involved the evolution of the Milky Way itself, and the deeper researchers looked, the more dynamic that evolution appeared. Computer simulations became particularly revealing. When astronomers modelled galaxies over billions of years, they discovered something remarkable. Spiral arms frequently emerged, disappeared, merged, separated, reformed. The structures were far less permanent than earlier generations imagined. Galaxies behaved less like carefully engineered machines and more like weather systems. Patterns emerged from underlying processes. Those patterns evolved. Some survived. Others vanished. The Orion Arm may represent exactly such a pattern. Not eternal, not temporary in a human sense, but transient on cosmic timescales. A structure that exists now, yet may look dramatically different hundreds of millions of years in the future. The thought feels almost unsettling. The cosmic neighborhood humanity calls home is not fixed. The address itself is evolving. The roads are shifting. The landscape is changing. And we happen to exist during one brief chapter of that process. Perspective becomes essential here. Human civilization spans a few thousand years. Recorded history spans a few thousand more. The Orion Arm evolves across hundreds of millions of years. The Milky Way evolves across billions. The difference in scale is difficult to comprehend. Imagine a mayfly attempting to understand continental drift. That comparison still understates the challenge. Humanity observes only an instant of galactic history. Yet from that instant, we attempt to reconstruct the whole story. Remarkably, we succeed more often than one might expect. The reason is evidence. Motion leaves traces. Structure leaves traces. History leaves traces. The galaxy preserves clues, and astronomers have become increasingly skilled at reading them. Those clues suggest that the Orion Arm occupies a particularly interesting position within the Milky Way. Not central, not peripheral. A transitional region, a place where multiple influences intersect, a crossroads within an evolving galaxy. The analogy of a city returns once more. Some districts exist at the convergence of major roads, trade routes, and populations. They become dynamic, active, constantly changing. The Orion Arm may occupy a similar role on galactic scales. If true, that possibility helps explain much of what researchers observe. The abundance of star-forming regions, the complexity of stellar populations, the evidence of repeated disturbance, the neighborhood's apparent significance. But another question now emerged, perhaps the deepest yet. If galaxies themselves are evolving patterns rather than fixed structures, what does that mean for humanity's understanding of place? Can we truly say where we are if the environment itself is constantly changing? The question sounds philosophical, yet it grows naturally from the science. The Orion Arm investigation began as an attempt to identify a location. It was becoming an exploration of process. The solar system does not merely occupy a place. It participates in an ongoing story. A story involving generations of stars, ancient collisions, evolving structures, endless motion. And hidden within that story lies an even more surprising realization. Because the closer astronomers examined the relationship between the solar system and the Orion Arm, the more intimate that relationship appeared. Humanity was not merely living inside the structure, we were embedded within its history, far more deeply than anyone once imagined. For much of this investigation, the Orion Arm has been described as a neighborhood. The comparison is useful. Neighborhoods provide context. They help explain location. They define surroundings. They create a sense of place. Yet the analogy contains a hidden limitation. A neighborhood implies distance, separation. You live in it, but you remain distinct from it. The deeper astronomers studied the relationship between the solar system and the Orion Arm, however, the less appropriate that image became. We are not merely residents of this structure, we are products of it, participants in it, expressions of it, and that realization changes everything. Imagine moving into a city. The city shapes your experiences. Its streets influence where you travel. Its economy influences your opportunities. Its culture influences your worldview. Yet you existed before arriving. You remain fundamentally separate. Now imagine something different. Imagine discovering that the city itself built you, that every part of your existence emerged from materials originating there. The relationship becomes far more intimate. The city is no longer a backdrop. It becomes part of your identity. The Orion Arm occupies a similar role in humanity's story, because every atom in your body carries a history connected to ancient events that unfolded within regions like this one. The realization begins with stellar evolution. Hydrogen emerged shortly after the Big Bang. A few other light elements formed alongside it, but nearly everything else required stars. Carbon, oxygen, silicon, iron, calcium. The elements composing planets, oceans, mountains, and living organisms originated inside stars. Many formed within massive stars that lived and died long before the Sun existed. Those stars belonged to earlier generations inhabiting the Milky Way. Some almost certainly occupied structures ancestral to the modern Orion Arm. Their deaths enriched surrounding space. Gas clouds inherited those elements. New stars formed, new planets formed. Eventually, the solar system emerged, and with it, Earth. The implication is profound. The Orion Arm did not merely provide humanity's location, it helped provide humanity's ingredients. In a very real sense, our existence is connected to the evolutionary history of this galactic environment. The relationship resembles less a neighbor and more a family lineage. Yet even that analogy may be insufficient. Because the solar system continues interacting with its surroundings, the relationship did not end 4.6 billion years ago. It persists today. The Sun moves through interstellar space. The heliosphere, the enormous bubble generated by the solar wind, continuously encounters material from the local galactic environment. Cosmic rays penetrate the solar system. Interstellar particles drift inward. The boundary between local space and galactic space is surprisingly porous. We often imagine Earth as isolated, protected, separate. In reality, the solar system remains connected to the larger Orion Arm in subtle ways. The roommate analogy begins to make sense. A neighbour lives nearby. A roommate shares the same environment. The Orion Arm is not merely around us, it surrounds us, influences us, flows through us. The distinction matters because it changes how we think about location. When people ask where Earth is located, the answer often seems straightforward. Third planet from the Sun, inside the solar system, within the Orion Arm, part of the Milky Way. Yet each layer reveals a deeper connection. Earth exists because of the Sun. The Sun exists because of earlier generations of stars. Those stars existed because of galactic processes unfolding across billions of years. The chain extends outward indefinitely. Location becomes history. History becomes identity. Astronomers increasingly recognize this interconnectedness while studying stellar populations throughout the Orion Arm. Young stars inherit material from older stars. Planetary systems inherit material from previous generations. Entire regions participate in cycles of birth, evolution, and renewal. The Orion Arm functions less like a static structure and more like a continuing conversation between different eras of cosmic history. The solar system represents one sentence within that conversation. The realization invites another perspective shift. Throughout human history, civilizations often imagined themselves as isolated centers of importance. Scientific progress repeatedly challenged that assumption. Earth was not the center of the solar system. The Sun was not the center of the galaxy. The Milky Way was not the center of the universe. Each discovery reduced apparent centrality. Yet something interesting happened along the way. Humanity lost privilege, but gained connection. We are not central, but we are connected, deeply connected. The Orion Arm investigation illustrates this perfectly. At first, the mystery seemed geographical. Where exactly are we? Now the question appears more existential. What exactly are we part of? The answer extends beyond coordinates. We belong to a dynamic galactic environment, shaped by billions of years of evolution, an environment that produced the materials composing our world, an environment that continues influencing the solar system even now. The perspective is simultaneously humbling and strangely reassuring. Humanity is tiny, yet humanity is not separate. We are woven into a much larger story, a story stretching across tens of thousands of light years. And that story contains another surprise, because when astronomers compared the Orion Arm to similar structures in other galaxies, they noticed something unexpected. Our neighborhood may not be unusual. In fact, it may represent a common outcome of galactic evolution. The implication sounds ordinary. It is not, because if structures like the Orion Arm are common throughout the universe, then environments capable of producing planetary systems like ours may also be common. The thought expands the scale of the mystery once again. The investigation is no longer merely about the Milky Way. It is becoming a question about galaxies everywhere, and perhaps about the conditions under which complexity itself emerges. The Orion Arm had already transformed from a minor spur into a major structure. Now it was becoming something else entirely, a clue. A clue pointing toward patterns repeated across the cosmos, and following that clue would force humanity to confront a startling possibility. Perhaps our galactic home is not exceptional because it is unique. Perhaps it is important because it is typical, and that realization would open one of the largest questions in all of science. For thousands of years, humanity looked outward and searched for uniqueness. Ancient cultures imagined their lands at the center of the world. Later generations imagined Earth occupying a privileged position in the cosmos. Even after science dismantled those beliefs, the instinct remained. We continue asking whether our location is special, whether our circumstances are rare, whether our existence occupies some exceptional place in reality. The Orion Arm investigation seemed destined to reinforce that instinct. After all, it is our home, the region that produced the Sun, the environment that helped shape Earth's history. Surely it must possess some extraordinary characteristic. Yet the deeper astronomers looked, the more surprising the answer became. The Orion Arm may be important precisely because it is not unique. This realization emerged gradually through observations of other galaxies. For centuries, the Milky Way was effectively the only galaxy humanity could study in detail. Everything else appeared as distant smudges of light, beautiful, mysterious, frustratingly inaccessible. Modern astronomy changed that. Powerful telescopes began revealing galaxies across the universe in astonishing detail. Spiral galaxies became especially valuable. Each one represented another experiment conducted by nature, another opportunity to compare our home with other cosmic environments. Researchers started noticing familiar patterns again and again. Galaxies displayed structures resembling the Orion Arm, not identical copies. Nature rarely produces exact duplicates, but recognizable relatives, secondary arms, bridges, branches, complex regions connecting larger structures, dynamic zones rich in star formation. The similarities were difficult to ignore. At first, this seemed to diminish the Orion Arm's significance. If such structures are common, perhaps our neighborhood is ordinary. Perhaps there is nothing remarkable about it. Yet the opposite interpretation soon emerged. Common structures can be extraordinarily important. Consider coastlines on Earth. They are not rare, yet they play crucial roles in ecology, climate, trade, and civilization. Their ubiquity does not reduce their significance. It increases it. The same may be true of structures like the Orion Arm. They could represent recurring environments where galaxies organize matter into productive regions. Regions where stars form efficiently, regions where planetary systems emerge, regions where chemical complexity accumulates. The possibility carried profound implications, because it connected galactic structure to one of humanity's oldest questions. How common are worlds like ours? The Orion Arm investigation had begun as an exercise in cosmic geography. Now it was intersecting with astrobiology, the study of life's potential throughout the universe. The connection emerged naturally. Planetary systems require heavy elements. Heavy elements require earlier generations of stars. Those stars form within galactic environments. Location matters. History matters. Structure matters. The chain links everything together. Researchers examining exoplanet populations discovered another intriguing pattern. Planetary systems appear astonishingly common. Thousands have already been identified. Many more almost certainly remain undiscovered. The Milky Way may contain hundreds of billions of planets, perhaps more. The realization is staggering. For most of human history, Earth appeared unique by default. Today, uniqueness requires evidence. The burden of proof has shifted. And if planetary systems are common, then environments capable of producing them become especially important. The Orion Arm may represent one such environment, not because it is exceptional, because it is effective. The distinction matters. A fertile valley need not be rare to support civilization. Its significance arises from what it enables. Similarly, the Orion Arm's importance may derive from its role as a galactic nursery, a region where the conditions for complexity repeatedly emerge. The thought expands the scale of the mystery dramatically, because once you begin comparing the Orion Arm to analogous structures elsewhere, another question becomes unavoidable. How many other suns exist in similar environments? How many Earth-like planets orbit those stars? How many histories are unfolding right now inside distant galactic arms? The numbers become difficult to comprehend. The Milky Way alone contains hundreds of billions of stars. The observable universe contains hundreds of billions of galaxies. The multiplication quickly exceeds ordinary intuition. The cosmos begins feeling less empty, less isolated, more interconnected, and yet uncertainty remains, because abundance does not guarantee similarity. The existence of many planets does not guarantee many Earths. The existence of many Earths does not guarantee many civilizations. The mystery persists. The universe reveals possibilities without providing final answers. In that sense, the Orion Arm mirrors astronomy itself. Every discovery expands knowledge. Every discovery expands uncertainty. The two grow together. Researchers also notice something else while studying external galaxies. Structures resembling the Orion Arm often appeared transient, not permanent, not eternal. Features emerging from larger processes, features destined eventually to change. The realization carried an unexpectedly emotional quality. Human beings often attach permanence to places, cities, countries, homes. Yet even those structures evolve. Galactic structures do as well. The Orion Arm existed before humanity. It will continue evolving after humanity. The solar system occupies only one brief moment within its history. Perspective widens again. The Orion Arm no longer appears as a static setting. It becomes a chapter in an ongoing cosmic narrative, a narrative repeated in different forms throughout the universe. And suddenly, the original mystery acquires a new meaning. Why does our solar system feel lost inside the Orion Arm? Perhaps because the structure itself is part of something larger. A pattern embedded within another pattern. A story embedded within another story. Humanity searched for a precise address. What we found instead was a hierarchy of connections extending outward without obvious limit. Planet. Star. Arm. Galaxy. Group. Cluster. Cosmic web. Each scale reveals another layer. Each layer reduces certainty. Each layer increases wonder. The Orion Arm was never merely a location. It was a gateway into larger questions about structure, complexity, and existence itself. And those questions now pointed toward the final phase of the investigation. Because after examining the Orion Arm, the Milky Way, and galaxies across the cosmos, one unsettling realization remained. Humanity still has never seen its own galaxy from the outside, despite everything we have learned, despite every map, every survey, every model. Our understanding remains indirect. The greatest map we have ever created is still partly an inference, and that fact would lead directly to the deepest mystery of all. There is a strange irony at the heart of this entire story. Humanity has photographed galaxies billions of light years away. We have observed the deaths of stars in distant regions of the universe. We have mapped ancient light left behind by the Big Bang. We have measured the motions of worlds orbiting suns we cannot directly see. Yet we have never seen our own galaxy. Not truly. Not from the outside. The realization feels almost absurd. Imagine becoming the world's leading expert on a city you have never viewed from above. You know its streets. You know its neighborhoods. You know its infrastructure. You know its history. Yet you have never stepped outside its boundaries. You have never seen its complete shape. That is humanity's relationship with the Milky Way. And it is why the Orion Arm mystery remains unfinished. Throughout this investigation, astronomers have reconstructed the structure of our galactic neighborhood using evidence, distances, stellar motions, gas clouds, dust distributions, radio emissions, infrared surveys, Gaia measurements. The map has become increasingly sophisticated, increasingly detailed, increasingly convincing, yet it remains a reconstruction, a model, a scientific portrait assembled from clues. This is not a weakness. It is simply reality. Every map of the Milky Way is, in some sense, an act of cosmic detective work. The distinction matters because it reminds us of something essential. Knowledge does not require perfect perspective. Humanity has learned extraordinary things about the universe despite profound observational limitations. The Orion Arm itself is proof. A structure once considered a minor galactic feature gradually revealed itself as something larger and more significant. Not because we escaped the Milky Way, because we learnt to read its evidence more carefully. Still, the limitations remain, and they create fascinating uncertainties. For example, astronomers continue debating aspects of the Milky Way's spiral structure. How many major arms exist? How coherent are they? How long do they persist? What mechanisms dominate their formation? Different models emphasize different interpretations. Most agree on the broad picture. Disagreement survives in the details. The details matter because they reveal something deeper. The Milky Way is not fully known, even now, even after centuries of observation, even after Gaia, even after modern radio astronomy. The map remains unfinished. The realization becomes particularly striking when compared to external galaxies. A distant spiral galaxy may occupy only a tiny portion of a telescope image. Yet astronomers can often see its entire structure at once. Its overall shape becomes immediately apparent. The Milky Way presents the opposite challenge. We know vastly more about individual stars within it. Yet understanding the complete structure proves harder. The forest remains difficult to see from among the trees. This inversion creates a peculiar situation. In some respects, humanity understands galaxies millions of light years away more easily than the ones surrounding us. The statement sounds impossible, yet it contains an important truth. Perspective matters. Sometimes distance reveals patterns that proximity obscures. The Orion Arm illustrates this beautifully. The closer astronomers looked, the more complexity they discovered. The larger the structure appeared, the less certain its classification became. Knowledge increased. Simplicity decreased. The same pattern appears throughout science. Reality often grows richer under closer examination, not simpler. The Orion Arm became a lesson in that principle, a reminder that understanding rarely eliminates mystery. Instead, understanding changes the mystery. The original question was straightforward. Where exactly is the solar system located? The answer seemed simple, inside the Orion Arm, but each layer of investigation transformed that answer. What is the Orion Arm? How did it form? Why does it exist? How has it evolved? How does it influence the solar system? How does it compare with similar structures elsewhere? What does it reveal about galaxies themselves? Each question expanded the scale of the story. Eventually, the investigation stopped being about location entirely. It became an exploration of perspective, and perspective reveals something profoundly human. Human beings possess a remarkable tendency to search for certainty. We want clean maps, clear categories, definitive explanations. The universe rarely provides them. Instead, it offers approximations, probabilities, refinements. The Orion Arm embodies that reality. The structure is real. Its significance is real, yet its exact nature remains partly unresolved. And perhaps that uncertainty is not a flaw in science. Perhaps it is evidence that science is working. Because unresolved questions indicate active exploration. They indicate boundaries still expanding. They indicate knowledge still growing. The most dangerous moment in any field occurs when people stop asking questions. Astronomy has not reached that moment, not even close. The Milky Way continues generating mysteries faster than they can be solved, and every improvement in observation seems to create new puzzles, new structures, new anomalies, new possibilities. The situation resembles standing at the edge of a vast coastline during low tide. Each retreating wave reveals additional territory, more rocks, more channels, more hidden features. The farther the water withdraws, the larger the unexplored landscape becomes. The Orion Arm emerged from such a retreat, a hidden region gradually exposed by better observations. Yet beyond it lies an even larger mystery. Because if humanity still struggles to fully understand its own galactic home, what does that imply about our understanding of the universe itself? The question is unsettling, but also inspiring. Our maps have improved dramatically. Our perspective has expanded enormously, and still the unknown remains immense. The final stage of this journey would confront that reality directly, because the true significance of the Orion Arm may have little to do with galactic structure. Its greatest lesson may concern the limits of human knowledge and the extraordinary distance still separating us from a complete understanding of reality. Every map is a confession, not merely a declaration of what is known, a confession of what remains unknown. Ancient maps displayed blank regions labelled with uncertainty, uncharted seas, unexplored continents, forgotten territories. Modern maps appear more complete, yet the principle remains unchanged. Every boundary of knowledge conceals another frontier. The Orion Arm investigation ultimately leads to one unavoidable realization. Humanity's map of the cosmos is still unfinished. Remarkably unfinished. This fact can be difficult to appreciate because modern astronomy has achieved so much. We know the age of the universe. We know stars produce heavy elements. We know galaxies evolve. We know black holes exist. We know planets orbit countless distant suns. Compared with previous generations, our understanding seems almost miraculous. And yet, the closer we examine the foundations of that knowledge, the more uncertainty appears. The Orion Arm provides a perfect example. At the beginning of this story, it seemed like a simple feature on a galactic diagram, a minor structure, a cosmic side street. By the end of the investigation, it had become something very different. A dynamic region, a historical record, a star-forming environment, a partially understood component of a partially understood galaxy. Knowledge increased dramatically. Certainty did not increase proportionals. In some respects, certainty decreased. The pattern repeats throughout science. Each answer expands the horizon of questions. The effect resembles climbing a mountain. From the base, the landscape appears limited. Reach the summit and visibility improves. Yet the improved view reveals countless additional peaks beyond. The horizon expands faster than understanding. Astronomy experiences this phenomenon constantly. The Milky Way itself illustrates the point. For centuries, humanity did not know what the Milky Way was. Then we learned it was a galaxy. Later, we discovered other galaxies. Then galaxy clusters. Then superclusters. Then the cosmic web. Each revelation widened perspective. Each widened perspective revealed larger mysteries. The process continues today. The Orion Arm occupies one level within that hierarchy. A structure nested inside a galaxy nested inside larger structures. A pattern within patterns, and every layer contains uncertainty. Even basic questions remain active areas of research. How exactly do spiral arms form? How long do they survive? How important are density waves? How important are local instabilities? How strongly do galactic collisions influence structure? Different observations support different interpretations. The debate continues. Not because scientists lack evidence, because reality is complicated. The distinction matters. Uncertainty is often misunderstood. Many people assume uncertainty indicates weakness. In science, uncertainty frequently indicates sophistication. A field that recognizes its limitations is usually closer to truth than one that claims complete certainty. The Orion Arm investigation exemplifies this principle. Astronomers possess extraordinary amounts of data, yet they remain willing to revise interpretations. New observations arrive, models improve, maps evolve. Knowledge remains flexible. That flexibility is one of science's greatest strengths. The alternative is stagnation. History provides countless examples. Civilizations once believed the stars revolved around Earth. The belief appeared obvious. Observations seemed to support it. The model worked reasonably well until better evidence arrived. The lesson endures. Reality does not care about confidence. Reality responds only to accuracy. The Orion Arm repeatedly reminded astronomers of this truth. Every confident classification eventually encountered complications. Every neat explanation developed exceptions. Every apparent conclusion revealed additional layers. The mystery survived because reality proved richer than expectation. And perhaps that richness contains the deepest lesson of all. Human beings often imagine discovery as a process of reducing mystery. In practice, discovery frequently transforms mystery. The unknown does not disappear. It changes shape. The Orion Arm transformed from a question about location into a question about galactic evolution, then into a question about stellar history, then into a question about humanity's relationship with the cosmos. The original mystery never truly vanished. It expanded. This expansion becomes especially striking when viewed against the scale of the observable universe. The Milky Way contains hundreds of billions of stars. The observable universe contains hundreds of billions of galaxies. Those numbers are difficult to comprehend. Yet even they may represent only part of reality. Modern cosmology suggests that most matter in the universe is invisible. Dark matter dominates galactic structure. Dark energy influences cosmic expansion. The majority of the cosmos remains mysterious. Humanity inhabits a universe whose primary components are not fully understood. The thought is simultaneously humbling and exhilarating. We have learned enough to recognize the existence of deeper mysteries. That achievement alone is extraordinary. The Orion Arm occupies a small place within that larger context, yet it serves as a reminder. Even our own neighborhood remains partly unexplored. Even our own galactic address remains subject to revision. The frontier is not merely distant, it surrounds us. That realization changes how one thinks about exploration. The great voyages of Earth's history involved crossing oceans. Future voyages may involve crossing interstellar space. But perhaps the most important exploration is conceptual, learning to see familiar things differently, learning to recognize hidden complexity, learning to accept uncertainty without surrendering curiosity. The Orion Arm demanded exactly that. What seemed ordinary became mysterious. What seemed understood became uncertain. What seemed small became immense. And now only one final question remains. What does all of this actually mean? Not merely for astronomy, not merely for science, for humanity, for our understanding of place, for our understanding of reality itself. The final chapter begins there, not with the Orion Arm, not with the Milky Way, but with the strange position occupied by a curious species attempting to understand a universe from within it. At the beginning of this journey, the mystery seemed simple. Where are we? The question felt geographical, almost administrative, an attempt to locate the solar system on a galactic map. The answer appeared straightforward. Earth orbits the Sun. The Sun resides within the Orion Arm. The Orion Arm belongs to the Milky Way. Mystery solved. Yet the deeper we travelled into the investigation, the less satisfying that answer became, because location turned out to be only the surface of the story. Beneath it lay history, movement, evolution, connection, and uncertainty. The Orion Arm transformed from a place into a process, a living chapter within a galaxy that is itself still changing. And perhaps that transformation reveals something important about humanity's search for understanding. We rarely begin with the right question. The first question merely opens the door. The real discoveries wait beyond it. Throughout this documentary, a pattern repeated again and again. Every apparent solution generated a larger mystery. The Orion Arm seemed insignificant. Then it appeared important. Then it appeared dynamic. Then it appeared inseparable from broader galactic processes. Every answer expanded the scale of the investigation. The mystery grew because knowledge grew. That pattern mirrors the history of science itself. Humanity once imagined Earth as the center of everything. The idea felt natural. The sky revolved overhead. The sun crossed the heavens. The stars returned each night. Observation seemed to support the conclusion. Then the evidence changed. Earth became a planet. The sun became a star. The Milky Way became one galaxy among many. Every revision reduced certainty, yet every revision increased understanding. The Orion Arm belongs to that tradition, a reminder that progress often involves abandoning comfortable simplifications. The universe becomes larger, more complex, more beautiful, and more mysterious. There is another lesson hidden within this story, one that extends beyond astronomy. Human beings possess a powerful instinct to search for significance. We want to know whether our location matters, whether our existence occupies a meaningful place within reality. The Orion Arm cannot answer those questions directly. Science rarely provides existential conclusions, but it does provide perspective, and perspective can be surprisingly powerful. The solar system is not central. It is not unique in any obvious sense. It occupies one region among countless regions inside one galaxy among countless galaxies. The numbers are overwhelming. Yet something remarkable emerges from that realization. Meaning does not require centrality. Importance does not require uniqueness. A single page can matter within a vast library. A single note can matter within a symphony. A single world can matter within a galaxy. The Orion Arm demonstrates this beautifully. It is not the largest structure in the Milky Way. It is not the brightest. It is not the most dramatic. Yet within it emerged a planetary system capable of asking questions about the universe. That fact alone carries extraordinary significance, because the Orion Arm is not merely something humanity studies, it is part of the reason humanity exists. The atoms composing our bodies originated from earlier generations of stars. Those stars lived and died within galactic environments like this one. The solar system inherited their material. Earth inherited the solar system. Life inherited Earth. In a very real sense, the story of the Orion Arm and the story of humanity intersect. Not metaphorically, physically, historically, cosmically. And yet the story remains unfinished. That may be the most important realization of all. Despite everything astronomers have learned, the Orion Arm still contains unanswered questions. Its origin remains debated. Its future remains uncertain. Its exact relationship to larger galactic structures remains a subject of active research. The mystery survives, not because science failed, because reality is richer than any single explanation. The same is true of the Milky Way. The same is true of the universe. Every generation inherits an incomplete map, then adds new details. Future generations will almost certainly revise today's understanding. New instruments will appear. New observations will arrive. New mysteries will emerge. The process will continue. And perhaps that continuity is the real story, not the discovery of final answers, the pursuit of better questions. The Orion Arm investigation began with a search for our cosmic address. It ended by revealing something stranger. An address is usually fixed, a location written permanently on a map. The solar system's address is not like that. The Orion Arm is evolving. The Milky Way is evolving. The universe is evolving. Our location exists within motion. Our home exists within change. The address itself is alive. And perhaps that explains why the solar system sometimes feels lost inside the Orion Arm. Not because we occupy an insignificant corner of the galaxy, not because our neighborhood lacks definition, but because we are attempting to describe a moving reality using static language. We want certainty. The cosmos offers process. We want boundaries. The cosmos offers transitions. We want destinations. The cosmos offers journeys. The Orion Arm embodies all three. A structure that appears solid yet evolves. A neighborhood that appears familiar yet remains partly mysterious. A home that reveals new complexity each time we look more closely. And so we arrive at the edge of the map once more. Not the edge of the Milky Way, not the edge of the Orion Arm, the edge of understanding, a place humanity has occupied many times before, a place we will occupy again, because every answer eventually leads here, to a horizon beyond which additional questions wait. Perhaps future astronomers will finally resolve the Orion Arm's origin. Perhaps they will discover entirely new structures hidden within the galaxy. Perhaps they will one day leave the Milky Way and photograph it from afar, transforming reconstruction into direct observation. Perhaps. But even then, new mysteries will appear. New horizons will emerge. New maps will require drawing. The real lesson of the Orion Arm may not concern galactic structure at all. Maybe it concerns perspective. Maybe it reminds us that understanding is not a destination, but a voyage stretching from ancient stargazers to modern observatories, from Earth to the Milky Way, from the Orion Arm to the observable universe, and beyond. Because the universe is not merely larger than humanity once imagined, it may be larger than humanity can imagine. And somewhere within that vastness, hidden among rivers of stars, drifting clouds of hydrogen, ancient supernova scars, and evolving spiral arms, our small solar system continues its journey. Not at the center, not at the edge, simply inside the story. And perhaps that is enough. Or perhaps, like every mystery before it, the Orion Arm is quietly pointing toward another question we have not yet learned how to ask. And if tonight's journey through the Orion Arm left you looking at the night sky a little differently, let me know in the comments. I'd love to hear where you're listening from and what cosmic mystery you'd like us to explore next. If you enjoy these deep space investigations that blend science, discovery, and the bigger questions about our place in the universe, consider subscribing and joining us for future journeys. There are still countless hidden structures, unanswered questions, and forgotten corners of the cosmos waiting to be explored for now. Thank you for spending this time with me, wherever you are in the world. I hope you have a peaceful evening, a clear sky above you, and a renewed sense of wonder about the vast universe we all call home. Until next time, keep looking up.